Welcome back to the 43rd version of the large scale production engineering meetup. So we are in our 11th year this year. With this event, we are starting our 11th year journey. It has been quite long as far as meetup community's existence is concerned. Like you have different kind of mammals live with different ages, starting from human being to rats and all those stuff. But we lived. We actually lived a certain amount of time existed, and thanks to all the great folks at CRED, because otherwise I was wondering whether we could still do a physical one. So without further ado, I think Mitesh is our first speaker. Mitesh is kind of well known. We have been working in nearby tubes since Yahoo days. I could see many known faces back here. So until Srinivas fixes the stream recording, it's all good. So all request to the speakers that though the laptop is there, what you have to probably do is you have to speak from here. Otherwise, we lose one of the recording which is supposed to go to the YouTube thing. Okay. And I don't know how many people are in Zoom. Welcome. You are all remote, and we'll continue to do this hybrid stuff. I think should be doable, not a big deal. Uh, with the welcome once again, and let's start with our first talk. Usually we do a round of introduction, but since with all the logistics we got a little bit delayed, so we'll start right now. Before Mitesh starts, I'll request Harish to introduce the CRED keynote.
Hey, hey, good morning, everyone. Sorry for the delay, but it's great to see everyone here back in person. For the last 2 years, the entire community has been kind of like working online and like we had tough time kind of meeting in person and kind of network. So once again, on behalf of Fred and rest of LSD community, I extend my welcome to all of you. So as Zada has already mentioned, LSP has been around for like almost last almost more than a decade, and basically like what many of us have seen is basically from the infancy of from physical servers spanning hundreds to thousands of nodes to the we started this community at the infancy of cloud, and what we have seen is the transition from those physical servers which span across hundreds of nodes and racks to like the virtual clouds. And as it transitioned, this LSP also has transformed from basically what people used to do customize things in their environment to and the whole ecosystem of large scale production engineering, or SRE as it is called, has evolved. And it's great so that we can share our knowledge we have acquired over the years and how we solve for certain all these challenges we face in our day-to-day life in our organization, so that we can that will help the community.
Welcome to CRED, and I would like to speak about the code pipeline, which we have started as a initial when startup starts. There was like generally developer concentrate more on towards development rather than deployment, and generally they do some manual deployment. GitHub pipelines, circles. So when we started, so nothing was there, and it was like we have to start with the practice session. If anyone is having any doubt or query, please interrupt, and you can ask so that the flow of question remains in the line with the presentation. So you can ask. No. Achha. Yeah. So today's agenda is history of CI/CD at CRED, means how we have started. So one we call it V1 because it was version 1 when we started, and it was presented in LSP in September 2019. And second is like we will explore the features what code pipeline V1 has provided, and it has helped us in deploying around 300 microservices. And then why we needed the second version, that we call it Caterpillar. And third, fourth one will talk advanced capabilities which Caterpillar takes care of, which will help us to scale further, and capturing the all future requirements. Even we don't know what requirements will come in future, so we have to create some platform which is able to take care of all those things. And we'll explain the architecture, and it will be giving the best practices which anyone can use, and they can create their own pipeline, and they will get benefit out of this presentation. And we'll show the scalability and reliability and its impact, how it has helped our developers, QA team, even SRE team. Many means it has touched even not only backend team, front end teams. So we'll see, and then we'll have question answer, but you can ask in between also. So it is completely interactive session. Yeah. So as I told, when a startup starts, the time to market is very crucial, and so if we try to use or build our own, right, the time is very less. So we try to use the available options to us. We evaluated various technologies related to code pipeline at that time, and we were using Bitbucket as our Git repo. So Bitbucket is giving Bitbucket pipelines, and our deployment was on infra, AWS. So we thought of like using Bitbucket pipeline, means AWS code pipeline first. But AWS code pipeline was not having integration with Bitbucket at that time. So that was actually blessing in a disguise that it was not there. So we have created our own integration with Bitbucket pipelines. So it has provided us rollback features, and so whatever Bitbucket pipelines provided the features we were able to use, and without exposing our infra to Bitbucket. Means every deployment happens by connecting the Bitbucket pipelines to AWS code pipeline. So we evaluated many things, and we have developed, and we want to maintain, because lean ops team means very less number of people were there. When I joined, I was the first person in DevOps and SRE. Then team increased to 2 or 3, not more than that when we started. So that was the main advantage by using means managed services. But we have created the glue code and integrated Bitbucket pipelines with AWS code pipeline. And that is already represented in LSP September 2019. And it brings agility. Let us solve this. Okay. Yeah. So i- we wanted like to give developers flexibility and uh, the means we want them to enable and keeping 10x growth in mind means when we started it was like 4 or 5 services and it is scaled up to 300. So you can see the 10x growth and it was able to handle with managed services and by creating that platform we utilize the experience of all developers uh, which were present initially and learnings from that. Yes. Yeah. So what happens? Next slide. Yeah. So in code pipeline V1, it was stateless. That is, no state is maintained anywhere. Means the code is state itself. Means once a commit is there, that is a state. So it goes through every means either say build means compilation of the code, then creating the Docker image out of it. That is again depending on the code only. So code is the state. So depending on the code, whatever we are committing, it is no place we are not having any database related to persist any data. Everything is coming from code pipeline. It gives a lot of flexibility and the time to market was crucial at the time. So this is stateless has helped us a lot. So as I told in previous slide that it was our learning experience we have utilized here and so we try to maintain as stateless as possible. So it helps us in like you roll back very easy because we can roll back to any version, not just previous version. And so that is the advantage of having stateless. Means every stage is immutable. Means if I run with same input, I should get same output. Second one is serverless. So we since we are not maintaining server like to run the pipeline. Say Bitbucket pipelines is run on and it is initially free for certain amount of time, so per month. So it was free for us, and so we are not running any server to run those pipelines. So that is the advantage, and no team means kind of no team is required virtually. So we can say it is kind of no operation team is there to maintain it. So and third point is self-serve. So developer can deploy their own pipelines without interacting with the operations team. Generally, we have seen the friction happen between dev and ops. Like I want this variable to be set. Means there is communication, and this delays the deployment. So developer is developing, he wants instant deployment, say within 5 to 10 minutes. So it gives like faster deployment cycles, and so since a developer is interested in more amount of like how much CPU is required, memory, what is there, they want to change the endpoint, all those things they are interested, but they are not interested where it is getting deployed, which cluster it is getting deployed, what are endpoints, so all those things. Any question regarding this? So fourth point is like as I told, it reduces the friction by using uh, hierarchical configuration. So means we have given developer enough set of configuration which they can tweak from their side, and we have given enough configuration for operations team, so they can set the things at global level or per service level. So we can like move service around between the clusters also, depending on say some are memory intensive, some microservices are CPU intensive, so we can direct those deployments also. And as I told, it is combination of AWS code pipeline and Bitbucket pipeline, and it was presented in LSP. So next slide. So what are the needs that we wanted to improve upon, like what we are using? Still we are using code pipeline V1 and it is running well. I mean, somebody wants to onboard faster, they are still using code pipeline V1. And these are the few needs to come from developers and QA team, various teams. So like they want to schedule jobs. So in AWS code pipeline, we can do scheduling using Lambda, but like it becomes like they'll cumbersome to maintain all those things. I mean, it looks hacky. So we wanted to avoid those things. And third, earlier it was like developer creates their pipeline. So that was half developer driven. Here developer even can define the in what stage what they want to actually run. Means earlier we used to provide like build environment for Java, build environment Python, or say Node.js or Golang. Here developer can create their own stage. So that gives us lot of flexibility. And even developers are creating their own stage. So we are removing one more task of ops team from the ops team to developer side. So we'll see advantage of this developer driven CI/CD. Third one is custom stages. So even like currently we are using ECS as a microservice orchestrator, but we can even deploy on self-created EC2 instance, Docker images, Ansible. We can install whatever we want. So it provides custom deployment stage. So even we are working on like using EKS also sometimes. For some jobs, those are required. The fifth one is chaining of build jobs. Say one microservice is dependent on another microservice. So if some deployment happens and other microservice wants to trigger some things related to it, so they can define the dependent jobs. So that is another thing we are providing in the V2. And last one is observability, means how builds are going. All those we can see with a nice graph, because we have integrated with Prometheus and Grafana. So, so we can see the some stats of Caterpillar in Fab. So we started migrating some services from prod to our services, and we can see the services are new services are there also, and we can see it is increasing. So red is prod deployment, and blue is stage. So what happens in stage, generally people test more things, so that's why stage is having higher number of deployments per day. And prod we deploy only after say if we do 5-6 testing, then only. So we can see initially in Feb it was less than 200 prod deployment. Now we have crossed around 300. So we are still more than halfway, but we are having around 450 plus, means 400 microservices and 500 total build jobs already there. And 650 deployments we are seeing average of per day. And we can scale up to 4,000 without like getting downtime. So how we have achieved these kind of numbers with minimal setup. So I know that many companies are using Jenkins and they are facing issues of stability with Jenkins. We have achieved some things that will be helpful for you to adapt. Any questions regarding these stats? Yeah.
Hello. Someone on Zoom asked how code is stored.
Yeah. So code means the code is stored in actually Git repo. So and every stage is having like cache. Means code is copied to cache. It remains there till the pipeline completes. Okay. So code comes, any code is pulled, and it is stored in say volume of Docker. Okay. and then pipeline runs accordingly. And the new code generated is shared between the containers using those shared volumes. Okay. So let us see. Slide. Have I answered the question? Or more details? Yeah. So this slide will share the means tell the components of Caterpillar. So as I told, I am also using Jenkins as a container orchestrator, nothing more than that. So if I use a Jenkins more than that, it becomes unstable. So that's why Jenkins is only used as a just as a means code pipeline as a code and just container orchestrator. It is doing nothing more than that. So by initially we thought of using other thing also, like I was thinking even to try Airflow. Jenkins is specially written for like code pipeline. So I thought first I'll try this. If it does not work, I'll move to Airflow. It worked well for us. And but I told we are like using systems such that it is plug and play. Like we have replaced two big components from our older pipeline, a Bitbucket pipelines and AWS code pipeline. So we try to design our things such that it becomes kind of independent from those the components which we are using. So if we feel like Jenkins is getting obsolete kind of thing, we can replace it with newer technology. So for now it is working well. So you can see source code repo is there, and to store. So cache gives us means a speed up of the communication between containers, and also like during builds many things are downloaded multiple times. To avoid downloading multiple times, it makes things faster. And these are like VMs, means easy to instances which are running Jenkins agent. So master does not do any work. It just schedules the container on those agents, and these are containers of every stage of a pipeline. Like we prepare the download. So prepare does the download of the code and massage it with the things, the configuration of developer and operation. And security is component like to scan the code for vulnerabilities and any secret or anything is stored in there or not. So it is also means a plugin inside plugin. Security is pluggable, and inside that also security team can plug multiple things like Docker file linting and other things that we have already integrated, and those can be controlled per service also. Third one is build. Build is in different color because this is generally the build given to developer so that they can create their own build space. Not means so we are not becoming bottleneck for developer now. So they can create. We are running Java 3 versions of Java with Maven and Gradle, different versions of Maven and Gradle. And Docker is ours because we deploy to Docker containers go to our ECR repo, and testing team creates the API testing and other things related to the service, and the deployment remains with us, and we can create even custom containers depending on the requirement. And all these three are metrics are going to Prometheus. Alerting is done in Slack and PagerDuty, and logging is done on our shared logging system, and it gives the feedback of how build goes. So it shares the feedback into the Bitbucket. Even you can share the status in GitLab or GitHub, whatever we are using. So the feedback is very important. It helps us in like getting the status of pipeline. So it say some PR is raised against that commit. So we can see if it is not green, we can ignore the reviewer can ignore the PRs. Correct? Yeah, question. Yeah.
Logging and security.
Yeah, so we have not used webhook. We have used like full method, and we push the status to Bitbucket.
Suppose,
Yeah, webhook also can be used, but we have not used it.
okay, so suppose if I raised a PR
Yeah.
and at the time, so the preparing security happens at that time or after the PR is merged?
So see, so PR you raise on commits, correct?
Yep.
If you commit something. So if commit is happening before even PR, means you know the status even before raising PR. That
Okay.
is the advantage. So with commit, every status is there. So in PR also that commit status is shown.
Okay.
Okay.
Thank you.
So that is the advantage.
So I didn't understand like where this ephemeral store is running, and this prepare security build Docker, right?
Yeah.
Are these running individual containers, or where are these running actually?
So
Same
these
is
are-
true with Jenkins.
Yeah, these are just component diagram. Means it shows the components of Caterpillar. So these containers run on these VMs, and this ephemeral storage is shared across multiple machines.
Got it.
What means like you can use S3 based copying. Means I told you it is pluggable. We are using currently Impel S3. Means we copy components here and, using S3.
And where is this Jenkins running?
Jenkins running on single instance. Only one machine is master, others are multiple machines.
Got it.
So we'll see how we can scale this. Next. Yeah, question.
So this Jenkins, is it same for all the microservices, or each microservice has its own Jenkins
No, no.
container in separately?
So we are having like federated Jenkins.
Okay.
So means one Jenkins is primary Jenkins is for crucial services.
Okay.
Secondary Jenkins is for like a cron job or say testing teams related jobs. So we can even like split. I've told every pipeline is independent of one another.
Okay.
So we can deploy anywhere. So that is the advantage, and it is coming from code pipeline as a code. So say developer does not want to say initially it was high priority. They are in primary. They can move their pipeline to from their side only. No need to contact me. So they can delete the pipeline from there. And in one click, they can click on site, create on second.
All of this happens on AWS, or this is a separate dashboard for you?
It means UI from UI.
From
Jenkins,
AWS, right?
Jenkins UI.
Jenkins UI. Okay, cool. Thank you.
Yeah. Next, any question or go to next? Yeah. So this is the flow diagram of Caterpillar. So developer commits, and it codes come to our prepare state, that is init CI/CD, and then securities. So we believe in shift left security. So as soon as code comes, we should scan, and if it passes, then only it will go to build. And initial testing we do inside one machine, like multiple VMs are there. So using Docker Compose, it is kind of ephemeral environment. So developer, if they write their full services like database and other things in Docker Compose, they can be easily testing inside one machine. But yeah, it is limited by the RAM and CPU of that machine. So we are going to extend that in next iteration. And after testing, a Docker is created for it, and it is pushed to our repo. And we have blue-green kind of deployment, blue-green plus canary. So initially green stack is deployed with zero traffic, so nothing gets affected here. And when API testing happens, we can increase the load in percentage based depending on the API test. If say initial health check itself is failed, there is no need of increasing traffic here. Say health check is passed, now increase to 5%, and test now whether endpoints are getting healthy, or means it is able to connect to database, and other things means if some changes are made, and we can increase up to say 20%. And after that, those tests are successful, it will roll back the traffic back to here and do rolling update on blue stack. So it reduces the number of RCS for us. So because if something happens, we can easily roll back traffic back to blue. Means our older version is taking all the traffic and nothing is going here. So in that way, we are able to achieve very less number of RCs as compared to if we directly deploy. So that is, and so in this is done in a stage. So once container is successfully tested in stage, same thing we do with in prod with blue-green deployment and API testing with container promotion. So build happened only once. That is the advantage. So we know same jar is going through all. So any doubt in this flow diagram? And if anything fails, alert is sent to the owner of that service. Yeah, promotion is automatic. Means they full write everything in code pipeline. So after this stage, that stage green stack of prod will be there. I'll show one demo.
Yeah, I have a question. So, how about managing the database changes while doing the blue-green?
Yeah. So database generally we are using like only incremental update in database, like adding a column. Okay. So yeah. So see, if you add one column, that won't means it is not as destructive as we are going to delete some column. So in rollback, the column deletion will not. It will be retained, and that is kind of related to database. Generally, those things are handled. Some things are handled manually. Yeah, I think
So basically, in that database, basically the database rollout and app rollout are kind of decoupled, and app is always backward compatible and forward compatible. So the app knows the columns which it is always going to use. So if there is a new column, it doesn't matter. See, even there, say the code still can be built like that, resilient of basically database changes. Yeah, the code can be resilient of database changes. That's how that's the only way. Otherwise, if for every deployment, if you want to kind of have a database change coupled with it, then that's going to have a huge downtime. And database changes, especially in databases of sizes of few hundred GBs or terabytes of sizes, you cannot make that change like in a second or minute. That may take probably a few days and well thought out planning. So database is always decoupled from code push.
any other question related to this flow diagram?
So does this pipeline run for every commit? Or
Yeah. So again, I told that everything is controlled by developer. So they can configure. They want to run it for every commit, or they can even put say before init they can put skip CI. So if they put a skip CI, and if your commit is having a skip CI or some regex, whatever you are using, means developer, it is okay. So if a skip CI is there, it won't run pipeline. Means your code will come here, but it won't run the pipeline. Yeah, means see here, say initial test, they can put one more stage. We have created one more stage, that pause until okay. Okay, it will pause the pipeline, and they can see the initial test. Anyway, if it fails, it won't go next stage. Anyway. So yeah, but some requirements may come, say if even the promotion they want to do manually, so we can use pause until okay there. If it is there. Means it is coming from their Jenkins file. Jenkins. It is Groovy, but we have not mandated anyone to learn Groovy. It is every stage is copy paste. So so that's what I told. Like it is like we have created things such that we can replace any component at any time. Next, it is previous. Okay. Features of Caterpillar. So again,
I have one question. So, are you using mono repo or multi repo?
we are using multi repo.
So, let's say there is one microservice and it's dependent on other microservices. So as we said, like one build run for one microservice, then there should be other builds run for other dependent services as well. So who will orchestrate all this stuff? Like,
Yeah, so I have told that we can do chaining of jobs. Okay.
yeah.
Yeah. So say you can define your. So we have simulated the mono repo with a common repo. So in common repo they can define the all things in proto repo format. Okay.
Okay, so
And so that is one root job, and the dependent services can be as a dependent on that job. And once you trigger the main root job, it will trigger all the dependent jobs.
okay, so it's written somewhere like the whole tree.
Yeah, yeah.
Of,
Means it is coming from code. It is nowhere like, and nobody is like creating pipeline from UI. So that if someone leaves, we can still recreate the same pipeline.
okay, thank you.
So yeah, these are features of code pipeline V2, but it is a superset of V1. So it takes care of all the features. Means we have like tried to retain all the features because we have seen all. Means it has given lot of means time for us to do much better things by using code pipeline V1, because we were not engaged in like daily uh, day-to-day routine jobs. So it has saved a lot of time, and so that's why we try to retain the same good qualities of V1. So that's why V2 we can say it is superset of V1. Means every feature of V1 is there, and so like self-service there. Here also developer is owner of their pipelines. They are able to create their own pipeline, but along with they can even create their own stage. So that's like their own build job, whatever they want to do, they can create. So that's how the proto repo problem is like solved by them, not us. Just I suggested the idea how we can use proto repo, means mono repo without creating mono repo. And it is fully auditable. Means once a deployment happens, by seeing the log we can go back to the actual commit. So who has done the commit and what changes were made, because we are taking based on git tag. So in logs also git tags are there, so it is easier to know what happened. It helps us in rolling back. Say we know that this was older git tag, it was running, we can roll back to older git tag in one click. So that is the advantage. So that's why we are generally what happens otherwise, if we deploy from Jenkins build number goes there in the deploy. So if we use that, then we have to come to Jenkins and see what is its build number mapping with what with commit. So that was like one more hop, and it takes time when some RC is going on. I mean, any issue is going on, it takes increase your time. So 6 environment, one stage, one dev, but in dev we are not deploying. Those are also going to increase. Some requests have come, so that's why single build environment creation is. Yeah. No, means no. Every service is like one. Say we are, for example, I give. We have two prod example. One is prod, one is PCI. PCI is also prod, but say it is having some stringent controls there. Okay, means for compliance. So either service can go to prod or PCI. So that can be defined by developer, not.
Only one environment as service code.
A service.
No, we have multiple also. Say from stage to perf to prod. Pre-prod is also we are planning to use. Multiple we can promote. That is not entrance. We are doing already 3.
What I meant is, for example, do you deploy in multiple regions? Do you consider each region as a different deployment, or
No,
it
no,
all goes to a
all
single?
3 regions we are considered as in Mumbai as single deployment.
It's a single deployment. Okay.
Means we have containers. Services are in 3 containers. Those containers can fall A, B, or C. It means anywhere. It can go anywhere. And So it gives us flexibility to create custom CI/CD stages, code pipeline as a code. So everything means earlier we are having infrastructure as a code, means every microservice goes as a code. Now here code pipeline is also coming as a code from developers side. So this is again super set, and we are supporting GitOps. So every operation is started from Git commit. Next one. Yeah. So we are supporting container promotion. This was not there in V1, and multiple deployments. Say so by having this feature, multiple deployment from same code base. This initially it looked just like a small feature we are providing, but it has helped us in lot of things. So first example is like say you are having a service which is like reading writing to a MySQL RDS. Initially load were less, so you are able to read write. Now you scaled a database to read replicas. So you can also scale your app based on say replicas. So your endpoints are replica now. There are two things: main service which is having write permission to main database, and replicas are having read permission. So you can control the things using same code only configuration tool. So this is the one example I am giving. Another benefit we got, say some feature someone wants to try in code, but with different endpoints. That can be possible. It is already we are doing. So this is the a good thing we have implemented several things and we are able to retain all those things from V1. And blue-green deployment with API integration testing, as I showed in flow diagram. So it gives us flexibility of running code in different set service and load balance the traffic between the blue and green, and if something goes good, then we can promote that green to blue. Otherwise, roll means discard that. And ninth one, we are providing Docker Compose based testing, means a service related all the resources which are created ephemerally on Jenkins agent, and they can test everything, and depending on the test container, if it succeeds we go ahead to next stage, otherwise it will fail the pipeline. So that is the advantage of Docker Compose based testing. So I hope our next presenter will be explaining about ephemeral when they have gone to next level with Kubernetes. So we'll see that from Intel. So we are doing this many things. These features have helped us. Like rollback is not needed if we are using blue-green deployment, or even if someone is not using blue-green deployment, they can roll back with one click because we have Git-based. Very and chaining of build. Yeah. Yeah. Okay. So I hope I have understood correctly. You are talking about like how does session we retain when we do deployment. Okay. Because what happens if session is there and container say from V1 is running and now you are deploying V2. What will happen to those sessions? Correct? Question correct. Okay. So what happens? We are doing rolling updates. So the older V1 containers are put into drained state when newer version containers are getting deployed. So older, so it is done in rolling update manner. So say 3 containers of say V1 are running. So one is put in draining, 2 are still serving, and V1 whatever session is there, it will be draining. So new connection won't go there. So in that way, so we have given 5 minutes timeout. So in 5 minutes, every connection are taken care of. So in that way, we are retaining the sessions. Means and session is actually shared using fast caches like Redis or Memcache. So those are retained there. So already means we are taking care of using like draining the containers before actually killing. So containers are put into drain state for 5 minutes. so that no request goes to it before it returns the all request it has come to. I hope I answered your question. Is this answer your question, Puneet?
Yes, yes, thank you.
Any other question? So yeah, yeah. So yeah. Yes. So these are features of Caterpillar: no ops, config-driven, programmable, build stage, mutually exclusive deployment. So one service deployment won't affect other until and unless dependent jobs. And CI/CD as a code, it make one-click CI/CD. Ability to support other kind of pipelines. It is not just we have created by thinking only for microservices, but we have supported data pipelines, which was presented in last previous uh, LSP. Rohit has presented for CI/CD for data pipelines. It is using Caterpillar for deployment, and we have even deployed Airflow DAGs using Caterpillar, and big data pipelines. Our data platform teams are using, and data science are also getting onboarded. So ML ops are. So how we have means it is running in distributed mode. So Jenkins master is there, and every stage runs on different agent. There is no guarantee that it will run on same machine. So in that way we got like scalability and no zero downtime. We have only one. We have stopped Jenkins only for upgradation of for IPL event. We have to upscale the master only. At that time only it was done, and for that also code pipeline was not down. Means we have V1 already running. Means somebody wants, and also for Caterpillar we have provided SAP, that secondary Jenkins master, which you can actually run their pipeline. As I told, it is one click, so they can create pipeline there, and if somebody is in urgency at that duration, they can come back. So we can say downtime was zero. So here you can see every run stage is run on different machine, and the data is shared. Say build has generated something. Say jar is generated, that is shared to Docker build using the shared cache, and we deploy. So we have achieved scalability and reliability using CI/CD as a code. We have portable pipelines when we can switch it from multiple if we are having multiple Jenkins master, we can remove from one and move to another. And it is stateless Jenkins master, and we are not storing any state in still in master or agents. It is everything is ephemeral there. Just like V1, we are not storing in state. Every state is coming from code, and the secrets are coming from secret store. So in that way, and say somebody is rolling back, that also can be done from there. And nothing shared architecture, and every stage of what we have built is immutable. Even the same input, it will generate the same output, no matter how many times you run. So this is how we have like achieved HA. So this is primary. Say if this is down, people can easily run their pipeline in one click here and there. So in that way it is HA. Anyway, but touchwood, this has not gone down since it is started around 2 years ago. So you can see now why it is named Caterpillar. It looks like Caterpillar. You can see number of stages it is able to cater. And the whole pipeline took around, which is having container promotion, API integration testing, blue-green deployment, and it took around 23 minutes. So you can see it is say building, and it is initially security is even, it was not integrated at that time. You can say build is there, only build is once, and it creates a Docker containers and for every deployment. And after that, it checks deploy in green stack, then it do API testing, and if API testing is successful, then only it deploys actual use. And then again, here it is promotion, so stage 2 PCI. And it deploys again in green stack, more. And again do testing, test PCI, then it deploys actual in blue. And blue, and it is parallel. And it deploys in actual last deployment. After that, it disposes the green stack. So cleaner. Any doubt in this system? So for security scanning, we are using Trufflehawk 3. And Docker linting, we are using Hardolink. And that is pluggable. Means here it was not there, but means it was created very long. So 23 July last when it started. Yeah. Now it is how you can see number of stages you have seen already, witnessed those things. So we have already moved the plugins from Jenkins server to developer server. So that has given us a stability in Jenkins server. We do not install any plugin in Jenkins server. So any request come for plugin, we say, can we run it inside container? If yes, developer can create it. Helps in creating custom plugins anytime. And developers are creating, even one developer has created, say he wants to try Golang 1.18 when it came. He himself has created that build stage himself by reading the docs. And just I'm giving another is Proto Repo. 60 plus plugin already created. So if you can imagine if you install 60 plugins of different versions of Java, several versions of Java, we are running 8, 11, 17, in future 18, 19 is already there. Several Linux distro, Debian, Ubuntu, Amazon Linux for like data science team, because EMR accepts only Amazon Linux built. Security stage for Docker file linting and Git code scanning, as I told, Trufflehawk. SonarQube quality gate check. It was not there in that. Now it is there. And it doesn't bloat the Jenkins. Next. So it is completely config driven and programmable. So we have taken best of both worlds. So it is config driven, generally copy paste. If it doesn't cater your requirements, you can program easily. So by combining the power of config driven, we have achieved a lot of things. Now AWS will come with Graviton. So next presentation is about Graviton. So we have also integrated those deployment on Graviton instance. So Java application we have started. So Akshay, how many applications we have migrated to Graviton? He is how much? So 45 applications we have migrated from Intel to ARM processor. And we are saving up to 40% in those processing. Utility tools of Caterpillar are being. So it is also like dog fooding. It is creating runtime images from. So earlier we used to create manually from base images we used to create manually. Now those are being created using Caterpillar because it has given programming capabilities. And build stages itself are also created through this. So if say any developer has written one plugin, it codes goes there, it determines which plugin he has written, it compiles it and automatically. Yeah, next. So what is the impact? So we have discussed with many developers who are using it and QA team, even our team also. So they are able to take informed decision on merge PRs. It is very helpful. So if any red is there, means no green is there, they simply ignore the PRs until some green is there, means last it should be green. Now developer control rollback. easily. Blue-green deployment helps in no RCA until means logical. Developer productivity has increased, and QA team are focusing on writing tests. Earlier, before Caterpillar, they were able to write around 11, 12 API tests. After this is there, now they are reaching around 80 plus. So that's the productivity increase for QA team, and for SRE team, it is less direct messages. Any question answer? Yeah. No, that is cost sharing. Performance difference is not much with the same set of, because Java is interpreted language, and if we run like a native language, then we see actual performance drop in ARM. But Java, it is same.
Okay, fine. So based on use cases, we have to decide.
Yeah. So
Thank
that
you.
based on it is just that's what it is. I told now operations configuration are with us, so we can change deployment
Switch
time,
whenever
switch
needed.
whenever.
Yeah, got it. Thanks.
Any other question? Yeah. No, promotion, container promotion is like just saying pipe means your container is already there. So if you don't deploy, it won't get used. So threshold, I come again. What is the minimum threshold? So API gateway actually hits, say API gateway hits the actual DNS. It doesn't know about the blue-green. So that's why it is transparent. So it doesn't know anything about the backend. So in that way, it is transparent to API gateway or client. So in that, and if you want a specific to green, then you can hit the different endpoint which we give. Anything else? I will share that. I'll share.
If there is no more question, then I think since we are running behind the time, roughly around 25 minutes, so we can take the other questions during.
Yes.
Okay. And we use some shrink a bit of lunch to make up the time. Okay. And we have, since we are here, we can obviously stay beyond. Okay. Thanks, Mitesh. Thank you very much. I mean, you are.
Thank you for providing the platform to.
Sure. Yeah. So Mitesh is probably, this is the third time Mitesh is presenting in LSP. It's known face, and IISc pass out. So you know. Thank you. So we'll invite Santosh Kumar from AWS. So Santosh works here in Bangalore office, Amazon Internet Services Private Limited. So we are part of a team called Support Engineering. So he is going to talk about the performance advantages of Graviton, which is now available in AWS. So take a quick, probably tea grab, and get back while we set up the stage for Santosh. Thank you. Take your seats so that we can start with the second talk. We're running behind the clock, so we'll try to make it up a bit. And the front rows, if you occupy photogenically, it will be good. Okay, thank you. We'll start. Over to you, Santosh.
Yeah, thanks, Devanshu. Okay, so let's get started. So hello everyone. Good afternoon now. So thank you so much for joining this session with me today. And I'll be talking about performance advantage of AWS Graviton processes for AWS users. Okay, in this session. Yeah, so my name is Santosh. I'm part of global support engineering team in AWS, and I'm also a EC2 Linux SME subject matter expert. So I work with customers to solve their technical issues that they might have while deploying their workload on AWS. Okay, so that's a quick round of introduction for me and what I do. Then so this is the agenda for today's talk. I'll quickly let you know about who we are and what we do as an internal team in AWS, and how that that should help you understand and relate to what we do. Okay, and then we'll talk about Graviton processes. What is Graviton processes? Then the latest generation of Graviton processes that we released recently. We will also talk about why we build our own chips. Then we'll talk about the managed services that we have, which is using Graviton, and why it is helpful for our customers. Okay. We'll do a quick demo on to show you, how to benchmark an EC2 instance, be it Graviton or x86. It's common, but I'll show you a quick demo on how you can benchmark and compare different instances and see if that particular instance suits your workload or not. Okay. Then we'll talk about strategies of migrating your application to Graviton. Like, what are the things you should consider before you migrate your application to Graviton, and what are the key things that you should be aware of. Okay. Then at the end, some the takeaway from the session. Okay. Okay. So I'm part of global support engineering team in AWS, and it's a global team, as the name suggests, and we have offices across the world. We work in follow the sun model, so we provide 24 hours 7 support to our all of our customers. Okay, and we do as a support engineering team, we do collaboration with our internal teams, very closely. We also work as a voice of our customers. So, you might be aware that most of our services that we build, right, it comes directly, from it originates directly from the feedback of our customers. What we hear from our customers, that translates to 90% of our services that we build. And so due to that reason, the feedback that we get from our customers are very important. We listen to those feedback very carefully and act on it whenever possible. Then we onboard new customers. We also onboard new customers with our technical account manager and solution architect team. We understand, analyze the use cases that we have. We help them achieve those use cases on AWS, and we onboard new customers to AWS platform. Okay. We troubleshoot technical issues for them. If a customer is stuck somewhere in implementing their workload or their architecture on AWS, if they are stuck somewhere, we help them to troubleshoot the problems technical problems that they have, and fix those problems for them. Okay. Then we continuously innovate the content that we have, public content that we have for our customers, right? Based on the interaction that we have from our customers, be it a interaction over the person, in person, or over the cases that we handle, for our customers. Based on those interaction, we try to identify the common patterns that is coming in from our customers, and based on that, we create knowledge center articles that you guys might have seen, right? In the knowledge center videos, like, these videos are not random, right? We try to analyze the data that we have and see what kind of cases are coming frequently, and then we try to put that content as publicly, so that more customers can benefit out of it, and they don't have to contact us directly to solve their problems. right? So this is all about myself and my team in which I work on. Okay, any questions over here? Okay, then let's talk about Graviton. So, if you talk about the choice of processors that AWS provides, we have, full range of processors that is available, including Intel. We have for AMDs as well as our Graviton processors, right? In Intel, we have Xenon scalable processors. We have many more, but in like majority of cases, we use Xenon processors. Okay. For AMD, we have EPYC processors. These are again like these are x86 based processors, and it's a very cost-effective alternative of Intel-based processors that we have. Okay. Then at the end we have these Graviton processors. This is ARM-based processors. These are our own custom-built chips that we use in all the Graviton processors, and it provides benefits like performance benefits, cost benefit to our customers, right? So let's dive a bit deep into it and see what are the benefits it provides. So talking about Graviton processors, these are 64-bit ARM processors, and like the version 2 of the processor that we have released, the Graviton 2 processors, they are basically Neoverse V1 processors. Sorry, Neoverse N1 processors, that is, and it is compatible with ARM version 8.2, right? So any workload that you run on ARM 8.2, that is going to run fine, just exactly the same way as on the Graviton 2 processors. Okay. Then in the Graviton processors, since it's our own custom build, we have the silicon is designed by us. We have done some targeted optimization in these processors. For example, in Graviton-based processors, we don't have SMT, simultaneous multi-threading, right? What it means is each vCPU that you get for Graviton-based processors, it is basically the physical CPU that you are getting, which is that is not the same as x86 based processor or instances that we have, right? In x86 based instances, the vCPU, two vCPU is basically one single physical CPU that translates to at the physical level, right? The other optimization that we have done in Graviton processors is there is no NUMA node in Graviton processors. So, I mean, there is no multiple NUMA nodes. There is only single NUMA node. So, if you have any application that is not performing well due to NUMA node configuration or any NUMA node problems that you might have, right? So, those applications, if you migrate to Graviton, it will have the best performance starting from its deployment. Okay, and then there are other enhancements, optimization that we have done. For example, for any instances that is that size is larger than 2x large, we have dedicated optimization done for compression workloads. So any compression, decompression that you want to do, there is a separate escalator that is built into all of the instances that is which is size higher than 2x large for Graviton instances version 2. So those workloads will automatically get a boost in Graviton based instances. Okay. So there are many more optimizations that we have done. I have just listed a few over here. And since the Graviton based processes are designed by us, it gives us it helps us to rapidly innovate and build more and more servers in less amount of time, and it helps us to bring the technology or innovation that we build internally into our customers' hands. Okay. Then AWS processors, these are designed for majority of the cloud workload that you can think of these days. For example, gaming web and gaming servers, high performance computing. We have media encoding, analytics, or databases, any open source databases that you can directly host on your Graviton EC2 instances, in-memory cache, electronic design automation, or even 3D 3D designing or computer modeling, right? Microservices based application that also can be hosted easily on Graviton based servers. Okay, talking about bit history of Graviton processors. So we started with, we initially launched our A1 instance type, which is of first generation of Graviton in 2018, and that helped our customers save a lot of money, right? And from there, from the success of version 1 Graviton processors, we launched our second generation Graviton processor in 2019, just 1 year later, right? And the instance types like C6G, M6G, these instances are for belonging to Graviton 2 processors. Okay, and then in 2018, 2 years later, we have launched we have announced Graviton 3 processors, and in this year May, we have launched new instance type called C7G that is using our newest Graviton processors, that is Graviton 3. Okay. So over the time, as I told you, having our own silicons helps us to innovate better, and that leads us to bring multiple instance type of different target for different use cases, right? So we have around 12 more than 12 instance family right now, based on Graviton based processor, and it is spread across 23 AWS regions globally, right? So the newest instance type that we have, IM4GN and IS4GN. These are these are next generation instances for i3 instances that you guys are aware of, right? So these instances also has our own design SSDs, our own custom design SSDs for better performance, right? So in these i4GN instances, right? These are they have more dense storage as compared to IM4GN instances, right? So per CPU, you will get more SSDs in IS4GN instances as compared to IM4GN GN instances, right? And this will help you, if you have any application that requires more, that is more storage intensive, and it requires more local storage to be used on, and it requires less CPU power. Then in that case, IS4GN instances are more suitable than IM4GN instances. Okay. We also have these G5G instances. This is the first ARM-based GPU servers that we have in any public cloud right now. Okay, and yeah. So any questions till here? Yeah. Sorry. Gaming. So gaming is generally it's a compute intensive application, right? So generally you use C4 instances in that. Okay. I mean, that is the general use case, but depending upon your application need, if it needs something else, you might want to choose some other instance type, right? But generally, the trend is that for gaming applications, you use C6 instances, and now we have C7, so you can use C7 as well. No. So C6G, so each instance family has their own processor types, and the underlying hardware for each of these instances differs. It's not the same. So I mean, if we have a C6G instance or C6 instances, I cannot modify it, make it like M5 or T4. It's not possible because the physical characteristics of those internal instances internally change behind the scene. Okay, and that's why it is targeted for different kind of workload. Like, for example, M6 instances are like M series instances are in general purpose for general purpose workload, right? T4G instances are for burstable workloads where you have your workload running for running at a specific performance level, and time to time it needs to go at higher performance level and then come back. For those kind of workloads, we use T-series instances, right? C6 instances are compute optimized. It means you will get more if your application needs more computing power, then you go with the C6G instances. R6 instances are memory intensive, memory optimized instances, right? So if your application is more towards it needs more memory to run, right? And if your application needs more memory per vCPU ratio, then you go with R6 instances, right? Then these are storage intensive instances, right? This is a next generation instances for i3 instance type that you are aware of, right? It has a lot of local storage as SSDs. Then G5 instances, these are our GPU based instances, right? And then same version we have G5G G as a Graviton, for the Graviton processor as well, right? Any other question?
The question is like Graviton processor which you manufacture, it's the same thing, right? It's just the configuration. Like for example, when you said memory intensive, right? Probably the bus speed is optimized for the bus speed. Probably like if you take the internal architecture, like how you have processor, right? And then you have memory bus there, right? The communication of memory bus or the cache in between them, these are optimized for that. And these boxes which you are giving, like R6G or whatever, right? They are basically configuration than the processor specific. The processor might be same, right? Say for example, you have a motherboard. You have your memory and you have your processor here, and you have your bus there. And usually what we do is we build this motherboard. There are specific motherboards for specific use cases, like gaming motherboards are different, general purpose are different, storage are different. You buy motherboards based on your requirements. The question is now, you have R6G, which are memory intensive workload, but what I'm talking about is the processors are same, right?
Yeah, the physical processors, right?
Are they
yes,
same?
Yes, in most cases, yes. Like if we talk about one generation instances, like Graviton 3, in most cases the processors are
same. So these are just the configuration, and there is no optimization at the process inside the processor for.
Yes, it is. Right? It is.
It is there. So
it is there.
So
depending upon the workload, like in some cases, for example, this C60 or C6 instances, I talked about optimization that we have done for compression workloads, right? So that is there only in these instances.
So the instructions, you are saying the instructions set on processors in C3, C6 and R6 are different?
In some cases, yes.
In some cases. So that means you have different versions of process. Huh?
Right. So yeah, the question was that in general, all the processes are same or not, right? So it's not the same. In some cases, it might be same. Like for example, for M6 and M and T, in some cases are same, right? But not in all cases. Like you cannot say that processors for M6 and C6 are also same. Right. Right. For some, like some of the instance type, the physical at the motherboard level, there are differences, but the processors are same for some of them, but not for all of them. Yeah. So some targeted optimization that we have done, right? So for that, there are some specific instruction set that we have provided for specific instances. Yeah, I mean, I'm not going very in detail on how exactly we do, but like in many cases, those things are kind of taken care of by our hypervisor team, right? We kind of spoof those kind of instructions that are coming in and then direct it to wherever it fits best. Those kind of optimization are also done.
Which is agnostic to the application. So application may be saying the same number of instruction pulling in. But hypervisor uses certain advantageous thing on changed platform.
I mean, the reason why we say these are ARMv 8.2 compatible is that the instruction set that you send from application level are same in most cases, right? But the underlying technology, how those instruction sets are handled, is different, right? Okay.
Hello?
No problem. I mean, we can discuss offline. Yes.
Yeah. So my question is like, so I think depending on the instance type, the mapping of a processor from hypervisor to the actual processor might be different. In non-computing intensive, there might be more processor is mapped to virtual processor mapped to multiple processor.
Sorry, the question is not very clear to me.
Means I'm saying that in C series you have one-to-one mapping, but in others you may not be having one-to-one.
Right, right. So you know, since
so
this is compute intensive, we have like more CPU to memory ratio. Like the CPU to memory ratio is high in this instance type. If you talk about R6 instances, memory to CPU ratio is high over there, right? So these ratios are not same. I mean, if you take a look at the instance configuration, what is the instance types we have and what is the amount of CPU and memory that is given for each instance type, you will be able to figure it out. So we have all this publicly documented. Does that answer the question?
You will have a north bridge and a south bridge. For a given processor, you will have a certain amount of memory bandwidth that you can use, right? Now, for the same amount of bandwidth, you can either assign it to your SATA, right? Like, if you are buying a motherboard of a given chipset, let's say on AMD, if you are buying an X470, right, you can either buy two PCI slots with 16x, or you can buy one with 16x and then a certain bunch of SATA, right? So it's basically for a given set of capability that you have, how do you configure that? Now, when you talk about something that is memory intensive, you might assign more channels for the memory. So the actual motherboard that the processor set might be different, right? So physically the machines might be different. Like on a GPU based machine, they might assign more for PCI layer, more channels for that, where you are assigning more memory to GPU to CPU memory and stuff like that.
ARM-based system where basically it's not a NUMA, it's a UMA rather than a NUMA. So there is a concept of North Bridge and South Bridge there.
So just that people understand, I didn't mean it had North Bridge and South Bridge. It's more of an it's just an example that I was giving.
So like all these questions that you guys are asking, that is very like specific to the processor implementation. So like maybe there are a lot of slides that I need to cover, but I would like to understand if there is any challenges that you guys have faced, so that I can answer those questions accordingly. Right. So right. So no GPU. This is Tesla based GPU that we have. Yeah, it's a Tesla GPU. So here in this case, the processors as well as the SSDs that we use in these instances specifically are from custom build. But apart from that, the GPU that we talked about, this is Tesla GPU, right? Tesla P4 GPU that we are using over here. Okay. So So like that is dependent upon the managed service team on their performance characteristics. If the instances are not matching the performance characteristics that they are delivering to their customers, like to let's say for Redshift example that you give, right? So they have some certain performance characteristics that they define for their product, right? If the instances are not matching that performance characteristics, they are not like using it in their product yet. But those are in pipeline and those will come soon. Yeah. Okay, so moving ahead. So talking about these C7G instances, right? So as I mentioned, we have in May 2000, like this year itself, we have launched this newest C7G instances, and it provides 25% better performance as compared to previous generation Graviton instances, which is Graviton 2, which already provided around 40% of price to performance benefits compared to other x86 based instances. Okay. Then it provides like 2x higher floating point performance, up to 2x faster cryptographic workload performance. Again, this cryptographic workload that we have done, it's another improvement that we have made in Graviton 3 as compared to Graviton 2. Okay, and then 3x better machine learning performance that this C7G instances provides as compared to Graviton 2. Okay. Then it is also the first instance that features DDR5 memory in cloud, and it is more energy efficient than any other silicon that we have. Okay, so it is more like around 60% more energy efficient over other comparable EC2 instances. So at this stage, the C7G instances provides the best price performance for any compute workload that you want to run in EC2, right? So if your workload is suitable for, or if your workload can migrate on ARM, then you can take advantage of the price and performance benefit that C7G instances brings, and you can migrate your application. I'll talk about migrating application to Graviton-based instances. What are the stages? What are the things that you should be considering on, towards the end of the session. Okay, so talking about some components of Graviton-based instances. So first we have the processor itself, and our own silicon build processor, which provides exceptional performance and also has lesser cost compared to other EC2 instances, x86 based instances that we have. Okay. Next, we have the Nitro chip. Nitro chip is integrated into motherboards of all the Graviton instances or Graviton servers that we have, right? The main use of this security chip is that it protects hardware resources from any unwanted behavior, you can say, or unwanted, malicious activity that is happening on the server, right? It also monitors the hardware overall. The monitoring is built into this security chip, and it also monitors the overall health of the server, and also provides monitoring like metrics in some cases, CPU metrics and those kind of things. Okay. Yes. Yes. So monitoring in the information in the sense, the data that it collects, it processes that data, and then the monitoring metrics you get for instances in many cases comes from here. Especially if you talk about metal instances, the monitoring data comes from here. Okay, then we have Nitro card itself. This is the card where lot of our hypervisor, so traditional hypervisor component that used to sit in hypervisor, now we have offloaded into this Nitro card. This is a separate card, which is separate from the actual server where instances run. Okay, and a lot of work of the traditional hardware has been uploaded to this card. For example, elastic block storage interfacing that has been uploaded to this Nitro card. The networking capabilities like elastic network adapter, ENA driver, and ELA modules that has been uploaded to this Nitro card. and monitoring and security of these interfaces, that that is uploaded to this card is also done through this Nitro card. And due to this, since all the major activity of the hypervisor has been uploaded to this Nitro card, we now again ARM. These are all these are all. What do you mean by protocols? Yeah, ENA. So ENA adapter. I mean, this is like SRIOV that you have, right? So at the physical level, whatever the network interface we have, it is offloaded to this network card, this Nitro card, and then this Nitro card provides all the network connectivity to the EC2 instances that we have. So the ENA driver that you install, it interacts with this Nitro card and provides the network connectivity to instance via this card. Right. Yeah, like you guys know VPC, right? So the VPC is not a physical network; it's a virtual network. And when you say virtual network, it is basically we have encapsulation at the network layer, and those encapsulations are done by this Nitro card in hardware. Yes, the entire networking stack has been uploaded to this card. I mean, that is how we are able to differentiate even the same private IPs in the same account in different VPCs, right? So, yeah, in general, the encapsulation process is not as smooth as bare metal network performance, right? And to match that performance, we have done this enhancement. And this is one of the initial enhancement that we have done with silicon processors in AWS, right? It was there much before then we have launched our first Graviton instance A1, right? So actually, the all the concept of having offload or having our own processor actually came from this use case. Okay. Cool. And then lastly, the Nitro hypervisor. This is very lightweight hypervisor that we have, and it only used for allocating CPU and memory resources for EC2 instances. All other work of hypervisor has been uploaded to this Nitro card, right? And that's why the newer generation instances that you have, it performance is much very similar to bare metal instance performance that we have. Okay. This Nitro card is the one that helps us create bare metal instances that we are having right now. No. So the M4 instances, it doesn't have this Nitro card. I mean, it does have, but not exactly the same. In instances before that generation doesn't have this Nitro card. So this Nitro card actually started coming in after M4. So M4 that is still Gen West, but it does have this Nitro card, this offload, and all the instances after that generation has this offload. Yeah. Yes, even M4, M5, M6, and then C7 now. Okay, so all the performance benefits that we talked about, right? How does it translate to our customer? How does our customer benefit out of it, right? So for that, the Graviton processors, right? It is one of the highest performing processors that we have across all the CPU or all the processors that we offer to in EC2, right? And These processors provide up to 20%, provided as 20% lower cost than comparable other instance x86 based instances. Okay, and these instances provides 20% more performance than other comparable instance types. So overall, our customers get around 40% better price performance on these EC2 instances, right? So using these EC2 instances, Graviton-based EC2 instances, there will be a good saving in terms of price, as well as there will be boost in benefit, right? And that's the reason wherever possible we recommend our customers to migrate to Graviton. Okay. Cool. Then the next question: why we build our own chips? So again, building our own chips helps us to innovate more. So you can think about that. We have engineers, or we have teams who design silicon, who works on hypervisor, who works on software stacks, who works on performance tuning and all those stuff under same roof, right? So it becomes easy, and it becomes very manageable for us to innovate end to end and target a specific optimization for a specific workload that our customer demands, and we are able to achieve that in a much lesser time as compared to general scenario where we do targeted optimization for a specific component in silo, right? So that's the benefit we get over there. It also helps us bring the newer technology to our customers' hands faster, right? One of the example is bringing, after announcing Graviton, you must have seen the frequency of instances that is coming in, specialized and targeted instances that are coming in, right? So we are able to, iterate more frequently and provide newer generation instances with specialized hardwares, to our customers more faster than previously. Then operation. This is one of the important thing, especially internally, like the newer chips that we have built, right? We have built capabilities to target or predict failures for our instances. That is not 100% yet there, but we have achieved a lot in identifying when a hardware might fail, right? And when we do identify that, we try to take actions before that hit our customers. So with this, we are trying to minimize the number of failures that our customers sees on their EC2 instances. Apart from that, we have also done some optimization at hardware level, which helps us change the code, or change the like hypervisor course, or do the deployment in without interrupting the workload that is running on EC2 instances. I mean, we can do live deployments, is what if I say in simple terms, right? So this helps us fix any problems sooner, identify any problem, and then deploy those problems, fix to those problems across our fleet globally much faster than we could have done previously, right? So these are the benefits that we are getting from having our own silicon, and that's why building our own silicon was a good decision. These are so here are some of the workloads, general workloads that we see on cloud, and its difficulty level if you want to migrate these workloads, right? So if you talk about RDS and these other managed services like Aurora, Elasticache, OpenShift, MemoryDB, or Neptune, these are all managed services that already supports Graviton-based nodes. So if you have any application that is running on these managed services, you can opt in for Graviton without much effort. You just have to do some few clicks on AWS console, and then your workload will start running on Graviton, right? Without doing much work in your code level, or at your application level, right? And running in Graviton will give you the benefit that it has, right? The higher performance and lower cost. Then other kind of application like EMR, where EMR also supports Graviton, and if you want to move your workload that is running on EMR to Graviton, you just have to launch nodes that supports Graviton based nodes, and then run your jobs over there, right? So that is also super easy. We have Lambda. Lambda also supports Graviton. So if you have workload that runs on Lambda, you just need to like select Graviton while having defining your function, and then you will be able to run your workload on Lambda. Only thing to watch out with Lambda is that if you are using your own images, and if you have done some optimization specific to x86 based instruction set, then those things will not migrate directly to Graviton, and you'll have to do further enhancement if you want to migrate those things to Graviton. So that is the only thing to watch out for if you are if your application is working on Lambda. If you have not done any specific optimization, or in case if you are not using any managed, like if you are just using the plain runtime that Lambda provides, then there should not be problem in migrating to Graviton. Okay. Then the other workload like running interpreted languages on Linux like Java, PHP, Node.js. For this, you just have to launch a EC2 Graviton based instance with ARM64 AMI, install all the like for example, if you have Java, so you install Java server over there, and once you have that, or if you are working on Node.js, then install the Node.js servers over there, and then migrate your code. So in most cases, if you again here also, if you have not done any optimization in your code that is very specific to x86, then your code will just run on Graviton servers as well, right? So migration of these interpreted based languages are also quite easy in most of the cases. Okay. In cases where you have languages that needs to be compiled like C, C++, Go, and Python, in some cases, you need to recompile your application before you move to Graviton, because the architecture changes, the instruction set changes, so you need to recompile your application before you move to Graviton, right? And then if you have Microsoft .NET based workloads, so Microsoft is not yet supported on Graviton, so you need to migrate that workload to .NET Core running on Linux, and then once you do the migration, do proper testing, then you can migrate that workload to Graviton. And if you have any other application that is running on Windows directly, then those applications will not be migrated to Graviton as of yet. Okay, any questions over here? Mm-hmm. Yeah, I mean, so one of the rule of thumb in adopting Graviton is that try to upgrade your infrastructure, or like the software stack that you are running to the latest level, because our team, they are not only working on silicon, they are also very heavily involved in community activity, where we provide new changes, new codes, and new optimization to the existing code that we have for multiple different applications. Okay, and whatever the new optimization that our team provides to the community, to the open source community, those things will be available only on latest version of softwares, right? So if you are migrating to Graviton, it is always recommended to upgrade your software stack to latest version and then migrate. That will give you the best performance that that is promised over here.
Another call out here is basically, say for RDS or Aurora, if your access pattern is primarily based on primary key or unique key, it works beautifully.
Mm-hmm.
But if you have some aggregations on top of your data, which you are running on Graviton, probably there is a slight degradation compared to the Intel based processors.
Yeah, so like we are not saying 100% of the workload that right now works on x86 based processor is it's going to work even the same or better on Graviton. Like that's not the case, but like what we are saying is majority of the use cases that you have, that we see on cloud, right? If you migrate to or if you try to consider Graviton processors in test your application, see if it works, and then you migrate to Graviton, you will have better performance in majority of the cases, if not at least the same performance as you see or as you get from x86 processors, as well as you will have additionally the lower, the price, you will get benefited from the lower price that Graviton provides as compared to other EC2 instances that we have. Right, so even if you are not getting any performance benefit, which is very rarely the case, but you will at least get the price benefit that Graviton has to offer.
That's definitely true.
Yeah. Cool. So talking about managed services supported on Graviton support on managed services, we have quite a few number of managed services that supports Graviton, like most of our database services, managed database services like RDS, Aurora, DocumentDB, Elasticache, or MemoryDB. All these are, all these supports Graviton. The analytics services like OpenSearch and EMR supports Graviton. Compute, in compute, we have Lambda, Fargate, Elastic Beanstalk. All these services support Graviton. In the storage services like Amazon FSx Cluster and OpenGFS, these are built on top of Graviton servers, right? So the performance or the performance in price benefit that Graviton has to offer is already in these managed services that we are offering. Okay. Then I wanted to show a quick demo on how do you do a benchmark on any EC2 instance as such and do the comparison between these two. So for this, I've selected this tool called Phronix. It's an open source tool, and it is it's available in GitHub. You can go and check the tool over here, like Phronix test suite. So the beauty of this tool is that you can run same test on any server that you want to run with a single command, right? And it runs exactly the same test on each server, so you get to compare the results of each server and understand how the performance benefit is you are getting from different servers, right? So that's the beauty of this tool, and that's why I selected to use this tool over here. These are some of the tests that I've run. There are more tests that I've run. I've just listed a few over here. And in the demo, I'll just be showing the first two because other tests take some time to run. Okay, I do have results that I've run and brought for all these tests, and I'll show you those results in the slide. But in the demo, I'll just show you the test for first two. Okay. Okay. So now let's move to. Okay, I have to. Is it visible now? Okay. So I already have few EC2 instances launched. This is sorry. Okay, the format is not good. I have designed it to fit my screen earlier. I have zoomed in now, so it's not showing very good. But EC2ls, this is just an alias that I have created for AWS EC2 describe instances. That is the command, and it lists whatever instances I have in US East 1, and I have these two instances running, which is C6G and C7G, and I'll be running performance benchmark on these two servers. Okay. So let me SSH to these instances. Again, SSH underscore EC2 user. This is again one of the alias that I have created for SSH command. So it's difficult to. this is better. Okay, now let me log into, so on top screen, on top pane, I'm logging into C7G instances, and then on the second one, I have C6G instance. Yeah, in this case, like we can compare the x86 based instances also. I mean, I don't have that launched and ready yet, so I will show you the results though. I have the results. I also have the links that I have uploaded after doing this test. So all the tests that you do via Phoronix, you can upload the results to a website called open benchmark.org, and I have already uploaded it, and I will show you the link where you can go and check. There are more tests that I have listed over here, and all those test results are available over there. Okay, so I need to install all the this Phoronix on this first. This is the new fresh instance, Amazon Linux 2 instance that I have launched, and it doesn't have anything right now. So I need to install the Phoronix. So for that, I will just go and download the Phoronix. I have the script, so I can take that from the script directly. So here is the, it is not on here. Okay, now I'll put the script over here. So this script basically, goes and downloaded to the Phoronix from this link, and then extracts that, and then installs that particular Phoronix, using this install.sh command. These are some dependencies that I'm downloading that is needed to run the test. Okay, so these are just yum install that I'm doing. This is another repository that NASM that I'm configuring. This is required for the test to run. So all these are dependencies, nothing else. Okay. So it will take just a few minutes, maybe at max, to run this install the Phoronix test agent. So just give it a minute. Top one. Okay, so one instance is done, another is pending, so it will be done soon. Okay. So now the Phoronix tool should be available for us to use. So this is the Phoronix tool, test suite it is called. I mean, there are different ways to run it. Like for you guys, if you are just getting started, you can just do interactive, and then it will display you the list of tests that it has, and then you can select the test and then run directly. Since I have done, I have already use this tool and run, I know the test which I want to use, so I can directly provide the test name and it can run that. Okay. Before that, there is also a batch mode that you can do. So every test, in every test, in most of the tests actually, you will have specific configuration that you need to provide, right? For example, if you are test for Apache, how many concurrent connection you want to use, or what is the total amount of time for which you want to run this test, right? So those inputs need to be provided. So if you are running directly, as a benchmark, and you need to provide that input for each and every test that you run, right? So to fix that, there is something called batch mode, and then in batch mode, either you can provide all the inputs by default, or you can provide all the inputs in one shot, and then the command will start running. Sometimes, like depending upon the test that you're running, it can run for hours, right? And you don't have to worry about like the inputs that you'll be asking in between, right? So that's the use batch mode, and we'll be using the batch mode over here. So setup batch setup is command that I need to run first in order to provide some initial setup. So it will be asking some simple questions. Okay. So questions like, do you want to open browser automatically? So save test results should be yes. So save test results yes, and no for everything else. Okay, it's done. Now we'll run the test. So in this case, we will be running two tests, as I mentioned. One will be for, okay, it started. So two tests that I'm running over here. Yeah, one is the compress BGP BZIP2 test, and another one is CRED. So BZIP2, what basically it does is it will download around a file of 1 GB, and it will compress and decompress that file using parallel BZIP2, and then compare the results of how much time it takes to unzip and unzip that file, right? The second test, CRED. CRED is basically a ray tracing kind of testing that is done. Ray tracing is one of the technology that is used in computer modeling, right? So that technique is used to do the benchmarking, and that is specifically used to do the benchmark for floating point numbers, for floating point calculations for CPUs, right? So it will take around 5 minutes to run. So while it is running, I'll show you the results on the slides, and then I'll come back to it later. So for CPU benchmarking, for parallel BGP2 compression, this is the result that I got for different instance types. So these are the instance types that I have used in this test. C6G, that is Graviton 2, and then we have Graviton 3, and then we have C6I and C6A. This is Intel based, and this is AMD based instances. Okay, and if you see the results for so I have taken C6G as the base, base for all the comparison, and converted all the numbers that I got, the times, into percentage. So here for C6G instances, as compared to C6G instances, the Intel the C6I instances performed around 48% lower, and then C6A instances performed around 12% lower, and then the C7G instances performed around 20% higher as compared to C6G, right? Similarly, for timed Linux kernel compilation, so what this test does is it takes the entire kernel code from the public repository and tries to compile the entire thing, right? And compares how much time it takes to compile those codes, right? And here also I have taken C6G as the benchmark, and as compared to C6G, C6I takes around 19% higher time, and C6A takes around 13% higher time. Okay, and then C7G provides you is able to compile the same code in 23% lesser time. Okay, let me see if the test is complete. it is still running. Oh, it's done. So top one is done. The bottom is still running, and it has started with test one for CRED. So it will take some time. I'll go back to the slides again. C6G. So I have used the instance type over here. This is for C6G 4x large, C6I 4x large, C6A 4x large, and C7G 4x large. These are the instance type I have used for all my testing. Yes. No. So I'm not doing any optimization. This is the base testing that I'm doing, and base comparison that I'm doing. Okay, I have not done any optimization as such. There are available in our websites. I have not included in my slide right now. Yeah, there are. These are available. Yes, it does. Yes, I'm not saying in all the use cases it does, but at least for compilation purposes or for zipping and zipping, I mean, for those kind of workloads, Graviton gives you better performance in all cases. Yeah, this is interesting. I'll come to this. So here, your questions will be answered here. So CRED, again, this is the result that we will expect the test that I'm running over here. So C7G provides around 40% better performance than C6G, and Intel has less performance, right? Then this FFmpeg, this is one of the open source tool that we have for video encoding, right? And then in this tool, when I run this test, without any tuning that needs to be done, this is the result I got, where C6G was performing, C7G was performing around 36% better than C6G, but the Intel and AMD based instances were performing much better than even C7G, right? Then I try to figure out like, is this the result that we expect, or is there any specific tuning that needs to be done in order to get better performance, right? And what I found out is the default FFmpeg test that we have on Phoronix, it uses some codec which is called MPEG1, and this codec is not very widely used across our industry. Like a lot of people don't use this codec to do the encoding, the workload that they do host for their applications, right? The one of the most popular codec that we have, it's called X264 codec, right? And that particular codec is kind of popular, and a lot of our customers use that codec to do the video encoding in cloud environment, right? And in that codec, our Graviton team has provided a lot of done a lot of contribution and done a lot of optimization. And then if we do the same testing with that codec, you will see the the result difference over here, right? So here again, even with that optimization, our the Intel and AMD performs better than second generation Graviton processors, but the 7th generation Graviton processors, Graviton 3 actually provides 40%, around 40% better performance than as compared to C6G. Okay. So any questions? So this example I specifically included to let you know that the importance of having latest software. I mean, this is the codec that I used over here. It directly came from the Git repository, public Git repository that we have from the main branch. So all the optimization that our team does, it directly goes there, and a lot of optimization that they have done, it is not actually merged in any of the release or included in any of the release that has come out, right? It will come in future releases, but those changes are very recent. That is the reason I stress on when you want to migrate to Graviton, try to have your software stack updated to as latest version as possible. That will help you in getting the best out of Graviton processes and the software contributions that our team does. Okay. Mm-hmm. I mean, yes. Yes. Okay. Cool. This is so. Let me go back to the test that I've run. So the test is now complete. I can show. Uh, and this is the test name. So in this case, it will just tell you the number, how much time it took for each of the performance result. It is not doing the comparison because these are on two different servers. So in order to compare that, what I'll have to do is the tests that I showed you, right? This test, there is a folder created with this name, and it contains a lot of files. I just need to transfer this file to one of these servers and then do merge test. And once you merge the test, then you will be able you show test results, and it will be able to show you the similar results as you have seen over here. But both the instances together, I mean, there will be one line for N1 and there will be one line for V1. N1 is Graviton 2 and V1 is Graviton 3. Okay. Okay, so that's about the demo. It was a quick one. This is just to give you some idea on if you want to do flat comparison on different instances that we have, right? If you want to compare which instance will be better for you, you can use this tool and do the benchmarking comparison. And then once you decide, narrow down to a specific instance type that you want to use, then you do the testing for your deploy your application on those servers, and then do the actual testing and see how your application behaves on those servers. Okay. Then okay, coming back to the slides, this is FFmpeg. I've explained about it. Then memory benchmark that I've done. This is a simple test basically does simple data copy from one place to other place in the memory, and checks the memory bandwidth that is available, right? In this case, we have seen Graviton superpasses all the x86 based instances, and C7G performs much better than even the Graviton 2. Okay. All these results are available in openbenchmark.org. So if you go to this link, you will be able to see there are much more testing that I have done and uploaded the results over there in comparison. So you should be, I have done comparison starting from M5, so M5, M5A, then all C6 instances, and then C7G. So all those comparisons are there. You can go and check. Okay. Okay, talking about migration stages. So, once you decide that you want to migrate your application to Graviton, what are the things you should be aware of? So, generally, we recommend to have two-stage migration policy for any application that you want to migrate to Graviton. In stage 1, you need to identify the dependency and check the status of it, right? So, yeah, I'm almost done. So in the first stage, you identify the libraries that you have. Like libraries includes libraries, dependencies, and agents, right? When you talk about libraries, it can be open source libraries, paid libraries, or commercial libraries. Everything you list down all the dependencies that you have for your application, right? Then you also find out the agents that you are using, like maybe for monitoring, for logging, or for security daemons, if you have any agents that you have. Once you have all the list, then check if all those dependencies, binaries, and applications have ARM support. It can be the binary that is available to you directly, or it can be the source code itself, that is not dependent on specific architecture is available to you, right? Once you have that, then once you've done these two stages, then you are ready to deploy your application on Graviton servers and do the testing, right? So in the test stage, you deploy your application on Graviton servers, do testing, as much testing as you can, right? At least do the testing that you are already doing for your application in x86 environment, right? That is the bare minimum. But in many cases, you might have to do some write some extra test cases if needed. Write those test cases and then test your application thoroughly and make sure your application behaves exactly the same way that you wanted it to behave on like Graviton based servers, right? Once you are done that, then the next stage where you update your infrastructure as a code. If you are using things like CloudFormation or CDK, you just need to make changes into it and ensure that it launches the Graviton based servers. So the changes that in this stage, the changes is not much. You just have to change the AMI and the user data of that reflects the Graviton 2 and it should be done, right? There are not much changes that is required as at this layer. And then the last is to deploy, what is the CI/CD pipeline you have. You deploy via that. The recommendation is to use blue-green deployment. But if it doesn't suit your application or your organization needs, maybe use your own CI/CD pipeline to deploy the application into the production, right? So this is the overall stage, migration stage that we recommend customers to follow. This has less chances of going wrong and then creating problems in the production, right? So you don't want to migrate your application to Graviton and at later stage and find out that there is something crucial that is not working the way you wanted to work, right? So all these things are very important before you migrate your application to production. Okay. Some resources about Graviton. This is one of the best resource that you can get about Graviton. Our GitHub page, getting started page. This page is maintained by our Graviton team, and it has all the latest knowledge that we have learned through different customers, right? So any thing that we have learned from our customers that is not working as expected will be updated here, and you will always find the latest information over there, right? So if you are getting started with Graviton, it's a must-go page. You must visit this page and see what other contents are available. There are high chance that the problem that you will be facing in your environment is already addressed over here. Okay, this is the performance runbook, another page, part of same GitHub repository, another page. It has, if there is any specific optimization done, we have done for our customers, other customers that has benefited them, those things are documented over here, right? This is another recommended link where we provide all the blogs or all our learnings that we want to share with our customers. So those things will come over here, and you should also check this place, whenever you are planning to use Graviton, right? So in summary, we have 6th generation EC2 instances powered by AWS Graviton 2 processors, which provides up to 40% better price performance over the comparable x86 instances. Then we have recently launched EC2 C7G instances powered by Graviton 3, and it provides 20% better performance as compared to Graviton 2 based processor, which already provided 40% price performance benefit on existing x86 based servers. Okay. Then Graviton based processors, it supports wide variety of workload that we have seen customers running in cloud, right? So most of the workload that you can think of, it is now supported by our Graviton processors. Okay. Then you can use most of the Linux distro, like almost all Linux distro now supports ARM. So you can run all Linux distro on ARM on Graviton servers. Okay. Yeah, and then if you are just getting started and wondering where to start using Graviton and get the benefit of Graviton, then you can start with this one using the managed services. So if you are using any managed services of AWS, and if you want to get benefit of Graviton, the first thing is to change that to Graviton, the managed service to Graviton if that supports it, and then from there you can start the Graviton journey. Okay, so yeah, that's all for the presentation. Any questions, last minute questions that we have?
Around an hour or 15 minutes behind our normal schedule. So what we'll do is we'll quickly break for lunch. Please keep on bugging Santosh during the lunch with all the remaining questions. Now we'll start the second hub at the 2:45 dot. Okay, so that we'll extend the end by half an hour so that we have both the talks covered.
Kind of cover your finish your lunch. We can kind of start fast.
Yeah, thanks everyone.
It's all on the speakers. Think about them, that they are staying up, so we have to stay up. Okay. So we have two gentlemen from Myntra talking about another CI/CD stuff, but obviously all implementation of CI/CD are different in the world. So let's hope this is an interesting talk. Another one. Okay. Check. Hey everyone, how are you doing? How's the food? That's a better question. Because depending on how the food was, if the food was good, then I'm going to have a very tough time. If the food is okay, then okay, we will have a little more attention. Food was good, really. I really liked it. So we're going to talk about large-scale ephemeral test infrastructure. Anybody have any idea what we're going to talk about from just the top line? Shout. Yeah, just go ahead, shout. Just replicating your, yeah. Right. Anybody else? Anything else? The second line, how we deliver large-scale projects in parallel. How many of you shopped at Myntra? Like we just finished off the sale yesterday. How much did you shop for? 10,000? 20,000? How much did you shop for? 7. Okay. Anyone bigger than that? No, there's no hamper for. There's no hamper. Anybody bigger than that? No? 8. All right. I think Ashutosh, you were right up there. 20. He's paying for getting salary from Myntra, giving it back to Myntra. All of that. All right. Moving on. So my name is Srihari. I lead the dev productivity engineering team. We deal with CI/CD, automated deployments, anything from commit to deploy, which improves the productivity of engineers at Myntra, enabling them to deliver large-scale projects cutting across multiple domains. All of that goes through our test infra, goes through our automated deployments, goes on to Kubernetes, goes on to virtual machines, all of that. So everything. All the tooling that is built around it, a lot of open source tooling, all of these connectors that we do for these toolings together so that developers have the best experience, all of that comes under our domain. Prahat's a senior software engineer. I'll let him introduce himself.
Yeah, hello everyone. Prahat Tyagi. I am working with Myntra as a senior software engineer. In Myntra I am working with developer productivity engineering team, and I'm making building few tools that will going to boost up the productivity of developers across the organization.
So if you want to hit us up on LinkedIn, GitHub, or any of the links, if you've noticed that, do send an invite. All right. So want to talk about a very generic note, not very Myntra specific. So that it is going to be much more useful for people. So I think way back in the 2010, 11, 12, at those times we had only virtual machines, no containers, nothing of that sort. I've had virtual machines, and
Myntra specifically also, if you look at it, we had around 60 to 100 engineers or so. And we were all sharing virtual machines. We say that, 3 o'clock to 4 o'clock is my slot for sharing that virtual. Anybody resonate to that kind of a nomenclature? Right. So, and then 4 o'clock to 5 o'clock is my slot, and usually the 4 o'clock guy doesn't get that slot, so it's pushed to the next slot. It was a mess. And then there was this huge influx of engineers into the company, and suddenly from like 60 to 100 engineers, we had like 400, 500 engineers trying to do many projects, all of them in parallel. Everything was P0. Everything had to be delivered yesterday. You see, so with the e-commerce, and it is, very fast-paced game at e-commerce. Amazon was coming into India at that point in time, and we were like, okay, this big, huge company was coming in, and no offense, man, but yeah, we had to do something, right? And then Flipkart kind of joined hands with us to let's fight for India. Let's be the Indian market. Let's not, really allow these companies to come in and, take over completely. But we had to actually support our test infra in such a way that we would be able to deliver products at the same pace as any other international company. And that was when Docker came into being, right? That was the 2015s where Docker was, this whole new model of removing this whole question. It works in my machine but does not work in your machine. It works in a container, it will work anywhere else, right? So that kind of a model came in, and then, Docker was a really good project until it wasn't. They came up with something called Docker Swarm. Has anybody heard of Docker Swarm? Now, have you heard of Docker Swarm mode? Anybody know what's the difference between Swarm and Swarm mode? It's very simple. Swarm didn't work, Swarm mode worked. It was an upgraded version of a Swarm, which they kind of concentrated. They were a containerization company in the end, and they did they kind of realized that it's okay to make all these 500,000, 10,000 containers, but who's going to do the orchestration around it? Right? And that's when they came up with, let's do a little bit of this orchestration business. That there's some company called, some project called Kubernetes that Google has created somewhere. I don't know, it doesn't work that much, but let's do it. We are the leaders at that point in time. That's when they started off with Docker Swarm mode and brought out this whole containerization model. But then there were bugs, there were issues, and we went through that cycle also. And we faced a lot of issues and minor features, breaking changes, and a lot of those kind of problems had to be fixed, and we found ourselves in office on almost every Saturday and Sunday. So didn't really work out that well. That's when Kubernetes really came out, different version. Even it was in a nascent form at that point in time, but we still wanted to try out, because the biggest difference, you see, is that Docker Swarm mode was doing 80% containerization, while it was just doing 20% orchestration. While Kubernetes was saying, bring in your own containerization, I'll give you 100% orchestration. And that was what worked for us. And that's when we moved on to, ephemeral test environments where each of our 400, 500 engineers could create test infrastructure on their own for themselves, for their projects, for their integrational tests, whatever the requirement was, on scalable Kubernetes clusters, which is scaled on demand. There were different concepts. We did not have ingress or some things at that point in time. Then ingresses came in, the service layer got upgraded, and then we did not have service meshes at that point in time. I think Istio, if you've heard of, was one service mesh which is just started at that point in time. Linkerd, if you've heard of, is another which had a version 1, which had started up at that point in time. But all of it was not stable. There were loads of problems, all of these new technologies that were going in place. So what we did is we built our own in-house service mesh. And Prabhat will actually take you through how that service mesh works and what are its shortcomings right now with the whole of the service mesh industry growing up and maturing. And then finally, we are currently, right now at a state, not Myntra, the whole community is at a good state right now where anybody can pick up a managed Kubernetes cluster from any of the cloud providers and then connect it with any of the service meshes they require and then, deliver it to their engineering teams. So we'll take you through that journey, taking you through the, advantages, disadvantages of, each of these models. So just to give you an overview of what Myntra is like, I talked about how we were at a 60, 70 engineering team. There was a 400% uptake on the actual overall service counts. We're around 400 odd actively used microservices at the company. But at that point in time, we could only serve around 1,000 test services running around. And right now, we can easily serve up to 5,000 services. And there are plans to scale this up even more so that using spot instances and things like that on the cloud where, whenever there is a big sale like what just finished, we can actually scale up and, bring it back down. Maybe test infrastructure is never used overnight or over the weekends. So we can scale it down at that point in time and save a lot of money during those points in time. And the total test environments we used to manage around, somehow manage, not even manage 10 to 25 odd test environments. Now we can easily self-managed, go up to a model of 400 to 500 odd test environments itself. Essentially giving one test environment for every single engineer that is there in the company. So these are the advantages that I've just ran through. Multiple projects cutting across different services. All of them can be executed in parallel. You're getting mutually exclusive environments, and that's how we get all these features. Sale after sale. We don't go quarter after quarter. We go sale after sale to our customers, and the mutually exclusive test environments are also useful for the business, where they can, quickly switch from one environment to the other and see if those features are what is expected in the production. And containers, like everybody knows, it's a common theme of, being able to create them faster. And it's so much more easier than the VM world where, some random environment variable was forgotten to be set by the DevOps engineer or whoever manages those environments, and it just such a waste of time at that point in time. And then finally, the cost that I just talked about on Kubernetes, where weekends or overnight, where there's no sale, everybody's gone for a vacation, maybe there's a downtime. All of the time, we really don't need the test infra. So now I'll switch it over to Prabhat for talking about the implementation. We'll take you through the pros and cons of the different varieties of networking. Please feel free to ask any questions during the course. If you have any questions right now regarding the first few slides, we can take a few questions. All good? All sleeping well? Not quite. All right, sir. Prabhat.
Thanks a lot, Shirley, for walking us through the evolution of test. And I'll just quickly walk you through the implementation or basically the improvements that we have made over these years. So basically, let's start with the VM-based approach. So there are a few VMs created in the QA environment, and these VMs were shared among the developers. They used to install their application in any of the one of the VM. They have to make few modifications in the HAP, the availability proxy, and few changes needs to be done in DNS, and they'll be able to access the service from outside this environment. suppose if somebody wants to access a service which is residing in VM1, for example, service 1. So this developer sitting outside this environment will try to access the resources of service 1. So it will call service1-qa.abc.com. The request, the DNS will resolve the host, and it will provide the IP, or basically the logical address of this app, which will responsible to further redirect the request to that particular VM, and the resource, the whole request will be served, and the developer will be able to access the resource. And there is one more environment out here, which is environment. So this is a look like production environment. So it's the most stable environment in whole test infra. There are services running, all these services running in this particular stage environment. Suppose if any of the developer wants to do some integration testing with any of the service, for example, service 4, the service 1 which is residing inside VM1 wants to talk to the service 4. So developer need not to add this particular service in any of the VM. This developer can just provide the stage address, and this particular service 4 can be used to communicate with service 1, which is residing inside VM. So this is what the fallback concept is all about. The setup of everything, it's look good. It is serving the our purpose of testing our applications. But what if that number of services goes up? Right now, 10 for 10, 20 odd services, this approach is quite good. What if the number goes up beyond 100, beyond 200? What the number of teams, developers, they'll go beyond a good number of number. Then what happens? Will it be able to serve our purpose or not? So let's just check few advantages and disadvantages in the next slide. So yeah, since it's a VM, so one of the best advantages we can have here is reliability. Even the VM restarts or anything goes wrong, then the data will persist. But let's see the disadvantages. We have more number of disadvantages compared to advantages. So no isolated environment services, since this one of the VM, for example, VM3 is being shared between few developers. Every single developer is setting up some environment variable. For example, some app name that application wants to access. So not two applications are having same environment variable. So they cannot use that particular environment variable. So this is one of the problem with the VM based approach. So no isolated environment for any of the service. The second problem is same port cannot be used by multiple services. Suppose if a service which is already running in VM3 acquired 8084 port, and I want to install one application inside this VM. So 8084 is already acquired by another service, and my service is also need that port. So I cannot install my application here in this VM. If in the worst case, if every VM is having some application running on that port, I have to introduce one resource, or so that's like I have to add some additional resource, then only I will be able to solve this particular problem, or I have to change my port. So this is one of the issue, and the third one is complexity. Like if I want to set up any new service in any of the VM, then I have to create some Ansible script which will help me to install this application. Then I have to make few updates in this proxy. The same update needs to be done in some DNS. So it's basically increases complexity of setting up of service. Then the manual efforts to update this HAP. Again and again, if I reinstall or if I remove any service or add any service in one of the VMs, then I have to again and update the HAP conf and then reload it. So it will going to use a lot of manual efforts basically. So suppose if one of the team they are working on some service, and they'll go and they'll reload the service. They have added one service. Likewise, some other team will go and they'll do some manual efforts. Like they'll update the core file and then they'll again upload the HAP. So there might be some chances that they'll ruin the configuration of some other service. So it will basically hamper the productivity of the other team. So let's see. We have made few improvements on this particular approach, and we have introduced Docker in our environment. So by introducing Docker, we have solved one problem which we were facing in the previous approach of isolated environment. Now every service is having their own isolated environment. They can set their environment variable as per their need, and no need to now worry about whether this particular environment has been used by somebody else or not. So that we have solved. Rest, the mechanism and the working is same only. Like we'll be resolving to the QA app, and QA will further redirect that request to the particular container, and the request will be served. And the fallback concept will also work in the similar fashion. So if we compare this approach with the previous approach, then we have just solved one problem, that is of isolation of services. That's it. Other scalability, manual efforts to update HAP, that is still there. If I want to add my service, then I have to again go to have to create one container and it will run on top of this, and I have to make some efforts to update the HAP. So that problem is still there. So we have already gone through all the pros and cons. So then in order to solve the problem of scalability, we have introduced KTS in our test infrastructure. So as part of this KTS, the moment we have introduced this KTS, so we have one KTS cluster, and inside this KTS cluster, we have created different namespace. So every namespace is representing a QA cluster. Suppose I want to create one QA cluster. So suppose I have named it as QA04. So this QA04, it represents a cluster which belongs to me only. I can add any number of services inside this QA cluster, and whatever. So the moment I'll add any service to it, that service will be having its own isolated environment. I can set whatever variables I want to set, whatever settings I want to set, I can set those settings. And even I can provide the CPU limit, or basically resource limit. Okay, this much CPU I want, this much memory I want. So all these things can be set on the basis of a service. But still, we'll be able to solve the problem of scalability here. Suppose right now let's consider that for this particular service, we have 3 pods running, and I want to do some load testing, and I want to use 6 replicas of the same service. I have to just add the deployment and I have to apply it. It will create those 3 more replicas for me without doing any manual efforts, without going inside the namespace and without installing each and everything from scratch. So Kubernetes will do that thing for me. So that's one of the best part of this Kubernetes. And apart from that, reliability is there. If I go with PVC, then I'll be able to hold whatever data I want to hold. If the pod restarts, or even if goes into the pod crashes, that can be easily held. But the issue that we were facing in the previous approach of updating the manually, that is still there. We have to update the app the moment any other service comes in any of the namespace. So that problem is still there. So let's see whether we'll be able to solve it in the next approach or not. Now you can see that there are few components that has been added. If we compare this diagram with the previous one, this component we have introduced, and apart from that, inside namespace, if you see, we have introduced few more boxes, one circle and one rhombus and one this square we have introduced. So let's see what this is all about. So earlier we were facing the issue in the previous approach of updating the app manually. So that problem we have solved by introducing an environment orchestration inside the namespace. So for example, if I have added any service inside the space QA04, service 4 I'll add. So this is a listener. What it does is, it constantly watches all the pods that are residing inside this particular namespace, this QA04. It watches the life cycle of pod, from pod creation to modification to deletion. The moment pod will be in the running state, this particular listener will go and update these 2 components. So let's talk about these two components. This component represents core DNS, and this is HAP, and this HAP in the previous approach used to be here outside this QA cluster, or basically this CRED cluster. It used to be here. So we have moved this HAP to inside this particular namespace. So this listener will go, and once these pods are in the running state, it will go and update the app with the appropriate configuration. And this core DNS, it will be holding the value of all the pods that are running inside it. And apart from that, if suppose if I add any service to it, for example, service 4, if I want to do some integration test with 4 service, which is residing inside stage namespace. So if that service is not available here, so I want this particular call to be fallback to this stage environment. So such type of configurations we need to put inside the core DNS. So this listener will help us to put all these things there in the core DNS. So suppose if today, if we get a call to, if I want to access this service C, which is residing under QA04 cluster, this call will be redirected from this component. Basically, the role of this component, there are two things. One is edge router and the second one is TCP router. So as part of this edge router, we have two things, HTTP and gRPC. So whatever HTTP request or call we'll get from outside world, so it will be routed through this edge router. So edge router will hold a key. Suppose for this service, this QA cluster 04, it will hold the address of that particular namespace inside this edge router. So if any HTTP request will come, this edge router will forward that particular request to this particular namespace, that is QA04. This particular app, it will be storing the IP address of this particular app. So whatever whatever request you will get, it will forward it to this particular app. And this app will be holding the configuration of all the pods which are residing inside this particular namespace. So it will further redirect that request on the particular port which we mentioned. Suppose this application is running on 8084. So it will forward that request to that particular port, which is for this particular service 6. So now no need to update or manually update anything related to app or core DNS. You need not to do that. And suppose if, let's take an example of any TCP service, MySQL server. Suppose if that is running in namespace QA03, and I want to communicate with that particular MySQL server. So this time, since it's a TCP call, so it will not be forwarded through this edge router. It will be forwarded through this TCP router. So this TCP router, it will be holding the key value pair, which will be so service 4-QA03.abc.com, and the port on which it needs to be connected to. This is, for example, in MySQL it will be 3306. So we'll store the 3306 against it along with the IP. So the moment it will receive the call, this TCP router will generate a port, some random port, post 20,000. It will pick a number, random number. Suppose it takes 21,000, and it will block that 21,000 port for that particular request, but the call it will be forwarded to 3306 for MySQL service. The call will be forwarded directly to that particular service, and the whole call will be served. So in the previous approach, we were facing the issue of manual update of HAP, and we have solved that purpose by introducing this one component, and the another component is environment orchestrator that we have created. It's our in-house service that we have created, which will solve the purpose of, or will remove the manual intervention to update the HAP. So we'd like to show a small, yeah, this much. This one, and this one, yeah. Yeah, TCP router. Pardon? It's a load balancer. Yeah. Yeah, it is in-house router. Edge router, yes. Both. Go. Go.
There is. I think we can discuss that. There is a way in which you can route HTTP, gRPC. Obviously not for TCP, but TCP is mostly port forwarding. All of these tools are all written in Golang. Yeah, we can share some code snippets for sure. Yeah, it's totally dynamic. So we have a bunch of persistent QA environments which are used for CI. But then, today I have a project, tomorrow I don't. I move on to another project. So I use it for a TTL of, let's say, 3 weeks or a month or a quarter. And we have mechanisms by means of which the QA cluster is expired and, it's cleaned up. So that we usually have around 200 to 250 BAU, but pre-sale, before the sale, and everybody's trying to get all of their code into production, gone up to almost 400, 350 odds test environments. And these are ranging from 2 or 3 services to 170, almost 200 odd services in one. Yes. So the name of the QA environment is the namespace's name, and use that to route. So right now, the current setup has a fixed set of worker nodes, but we have, our cloud provider has scalability on those worker nodes, scale sets. No, we don't allocate the namespace with resources. We allocate the namespaces with limit ranges, which forces pods inside that namespace to not go beyond a number. Now, if there is a requirement for a namespace to bump up that number and not be limited to they have doing something which is needing that much of resource, that is when we have to do a manual parse and increase those numbers. But on a generic scale, pretty much all of our services, 99.9% of our services don't need that manual bump up. It's only at that point in time there is any kind of an on-call ticket that comes up and say we want to bump this up a little bit. Right? Yep.
Ping mechanism. It works on the ping mechanism. It pings it and gets the detail of related to that QA, and it saves in memory database. And
mostly it's dynamically checking the whole namespace, right? It's one QA, one Kubernetes cluster. This whole thing. Right now it's got 200 plus nodes, 220 odds right now. Yeah. So somewhere on that range, and all we do is check all the namespaces. Look for the HAPs within each of the namespaces, save the IPs in memory. So whenever a call comes, right, you just do a map and look where it has to be redirected. If it's HTTP or gRPC, go to the HA proxy inside that namespace. If it's TCP, person itself has to choose the dynamic port that is generated by the system.
Service name hyphen QA namespace name. So along with that, it creates a mapping. So it acts as a key and store the IP address of app in Azure router. So
let's do the demo where you can actually see this happening, see how the HA proxy is getting updated, and we don't manually change any of these things with respect to the HA proxy configuration, with respect to the core DNS configuration, none of this. All of this happens automatic in the backend. So Prabhat, why don't you just quickly showcase? Right, so we call the system Dawkins, which is our test infrastructure system where people can come in, create, we call them QA clusters, okay? where you can create your cluster with any name. The TTL that we just talked about earlier. So there's a default TTL of 47 hours that you can create it with, because we really think containers and test infrastructure should be ephemeral, right? Because over time things go outdated and it may work for a while, but then you reset it, doesn't work, right? So 48 is the maximum. Whereas on the next page we'll also showcase how we can extend your TTL, because if you think there is a requirement for you to continue with that particular environment for some more time, you can extend it. The fallback environment right now is the stage environment. So QA is where you do all your feature tests. You do all your branches, your QA branches go and get deployed. QA drops to test engineers happen in this particular environment. But the fallback, because we've got around 400 odd active services at Mitra, I don't want to bring all 400 into this QA environment. That would be an overkill. So for anything that is not there in my environment, I would fall back to the pristine environment, which is stage. That's the configuration. Right now we just have one. Maybe later we will have different environments for forward and backward compatibility tests. So out of the list, can you just scroll up a little bit? Yeah. So out of the list of services, there's an auto suggest box which by means of which you can select, start typing in any of your services and select them. And these are all pre-configured information for the test infrastructure that dev teams configure, saying that this is for any service. Can you scroll a little more down? You can see the build type, the data center from where it's coming from, where the repo name right up top, the build command, the artifact that has to be generated. Keep going down. The base image, maybe some HA proxy URLs, host name, maybe some dependencies of services that are required, and maybe environment variables if you have to add them in. All of those parameters, health checks for the service. All of these pre-configured is a one-time activity for each of your services while you onboard the service.
And
right?
port you want to
ports, yeah. Right, so now what Prabhat is going to do is he's going to create, if you see there's still that fallback to Docker Swarm, which we've not removed, but now it's on Kubernetes. So there's an option here on this particular page for Prabhat to either use the stage image itself rather than building it again from whatever branch that is chosen. Let's just do the stage images because it's faster, the image is already pre-baked in, and all it takes is a little more time. Go ahead. So this creates a cluster, I think it's called the cluster LSPE Tech. Got a 20 RTTL on the cluster. And can you go down a little? Hang on. So on the top right corner, you see a lot of other features that we've built over time, things like Slack integration, snapshotting the data on that particular cluster, audit trail on who did what on that cluster, because what we've noticed is, when you have a huge project of 40-50 engineers working on, we really don't know who did what on each of these environments. So an audit trail of what happens. You see the build logs happening over here, and you see the different services that are getting built and deployed, bunch of environment configurations being added. If you go a little below and scroll down, you will see that along with Myntra Web, which is the service that Prabhat had created, there was another proxy service that was created along, which is the dependency. And all of this because the Myntra was tagged to this particular dependency. Now, if you open up the HA proxy. So earlier we talked about not touching any kind of HA proxy configurations and how it was automatically configured. So each QA environment gets an HA proxy configuration as well as a DNS configuration. And each developer can look into their HA proxy configuration, their DNS configuration, thereby giving them a little bit more motive to go and figure out whether something is missing in their system, rather than the platform teams going in and debugging everything for developers. So this gives, if how many of you know HA proxy and how to read stuff on the proxy. So it'll be very simple, very straightforward configurations. All we do is a bunch of ACLs and use backend for the services that are created. And the DNS configuration is the other URL that Prabhat has created. And if you notice, there are a bunch of DNS URLs which we've blocked out by adding 127.0.0.1, while the other ones, which are exactly your pod config, pod IPs, that's what we see. Now, Prabhat can pick up one of those URLs from the UI for the browser HE proxy service. So, can you go down?
Yeah, sure. Just give me a...
Yeah. So if you see right next to the Docker image that is created, there is a URL which is a very specific URL for that particular environment itself. So if you look at the URL is lsptech-browse-proxy.dockins.mintra.com, there is also an SSH command by means of which people can log in to these pods, and there's no password for it. It's again, this is also a Golang service which spoofs the 22 port and the SSH protocol and does an actual kubectl exec into the pod in the background, but it looks like an SSH command, that's all. But developers are more used to seeing that, okay, that's the SSH and more terminal access. Maybe we can show that also after this. But URL, can we pick up the URL? Let's see if it works. Yep. So this is a test variant of the Mintra website, which a developer has been able to open up within 2-3 minutes of sorts. And there are a lot more improvements on how we can push for that. So you want to do the SSH also?
Apart from that, Shri, show them the checkout also.
Yeah.
So we have not added the checkout service in our QA cluster, but still we'll be able to access it. So it is falling back to stage image. Whatever this particular service is running in stage environment, it is falling back to that particular service.
Yeah. Cart feels a little light, but still it is the checkout service. Right. Moving on to the SSH, you want to quickly showcase? It's very simple. Can you increase the? Yeah. Can you increase it a little bit? So a bunch of tokens and pieces that are said, Prabhat did not need to do any kind of password login, and there you are inside the browse HE proxy service, inside the container, inside the pod. Selectively, there are pods which are having services which are having multiple replicas. Where on the UI we can switch over to the different replicas if at all it is needed. Right, back to the slide.
Oh yeah. There's just two.
Second last.
So these are some advantages that we have gained over the previous approach. Isolated environments, we have its lightweight scalability issue we have resolved, and apart from that, one of the major problems that we were facing till previous approach was automatic updates to DNS and app that we have resolved in this particular approach. And one of the disadvantages, there are some features, service mesh features that are not still available, like circuit breaking and rate limiting. So when this service mesh, it was introduced, so at that time, just because of its maturity, we have not picked this thing up in our implementation, but surely we are working on it, and soon we'll be replacing our own environment orchestrator with the same. This, I think we have already discussed so many things around it. This core DNS, this is HAP reload and listener. Listener will keep on listening the create spot in that particular namespace. It will watch the whole life cycle of that pod, and as per that, it will update the DNS and HAP core file.
Right. So just the last slide on what is next for us and maybe for the industry also, on how cloud native open source solutions and service meshes like Linkerd and Istio have matured. Even Linkerd has a Linkerd version 2, which is written in Rust, much more faster, much more native. Obviously we'll not be able to match with publicly run program in-house. So that's one reason why we will be moving on to an open sourced service mesh. Again, the Kubernetes clusters had this thing of not leaving it to the cloud providers to manage. I want to manage my master nodes, right? But now it's just about a click of a few buttons, and I don't care about my master nodes. AWS or GCP or Azure, please just manage my master nodes for me. I don't want to know anything about those, etcd issues that come up. So that's the other thing. And then moving to load balancer services, so that you have single IP endpoints, better than the models that we have nowadays. And the improvement in the speed. So right now Prabhat was able to set up a cluster with a service within 2-3 minutes, reducing that even more. This is only for one service, so it is fast. But what if you had 20-30 services to be deployed? How would you make it more faster? And container best practices. That is something that the industry is all moving towards. Security, or the size of the images, the root access inside the container. All of those pieces are still, things that we have to implement and improve on these platforms. I think that's all we had for you today. Any other questions? We'll still be around anyway. Absolutely, absolutely. So we have a controller which, upon creation of a QA environment, creates the listener, updates the listener every time there's an activity done on that cluster. Yes, it is a cluster. It's a backend API which runs a Golang workload pipeline. All right. So any service that is not there inside your QA environment will fall back to the staging.
You're going back, falling to the staging.
Yeah, so that's one question that we always get. And what if two services talking to each other and back, are situated in a QA environment as well as in the stage environment? How would the callback come back into your QA environment? For that instance, usually this happens when you have queues in between, like a Kafka topic or a RabbitMQ or any kind of queuing messaging system. So the recommendation here is to bring both services inside the QA environment. There's no way to bring it back into the cluster once it's gone out.
Both services in one cluster.
In the same cluster.
Yeah. Another QA team is using that service in another cluster. So we can something like do key our namespace, that service namespace, and something like IP address we can directly mention in the app, that HTTP.
Correct. That would be a manual change, but the whole idea is to make it robust enough that there is no manual change needed, and any kind of suppose the whole Kubernetes cluster itself shut down, should be able to just spawn it somewhere else and bring up all the services. So at that point in time, all these manual changes, modifications will not really work.
Yeah.
So the recommendation is to not really have inter-cluster communication. If you want something, keep it inside your own cluster. If you want to bring another service that people are working in, bring that also. As maybe some other team's service you want, and they're running on some branch. So all you need to do is understand from them what are those services and what are those feature branches. Bring them into your cluster.
Okay, you set up something like that. Traffic goes down this much, or on a Saturday Sunday you are saying this is the increment. Yeah, means it will go down. That cluster will go down. That's already mentioned in the YAML file. Is it mentioned in the YAML file or where?
No, so the cluster does not go down. The configurations of the cluster may still be there. If a cluster is about to expire and there's no time left for it, it can go down. But the number of nodes, the 200, 220 nodes that are running up and running just to ensure that there is space for 400 test environments, that will reduce to maybe 150 nodes or 120 nodes, whatever is needed at that point in time.
Okay, node means the service.
The Kubernetes worker nodes.
Okay, worker.
All right, thank you very much.
Yeah. So folks, we have some goodies here. While Ashwin and others set it up, we will kind of distribute them. And like, I am it might be a bit shameless, but I would like to say that we are hiring. You can always reach out to me on LinkedIn, Harish Hardas. Or you can visit careers.cred.club. We have open positions across the board. So please do reach out to us.
Thanks, Harish. Okay, so since Harish is also doing distributing the goodies, I ignored that as from an organizer's self. Okay, so I think now it's there is a special name now. I was looking at the spelling for some time, then I figured it out. Is Akanksh. Still difficult. Okay, so Ashwin and Akshansh still can't pronounce it correctly. For the last but not the least talk from Ted. Yep.
Thank you. Thanks a lot. Hey guys, hi. Yeah, finally, the last talk. So you guys can go. So me and Akshansh want to present on one of the security frameworks that we had built. So in the first talk, you might have seen Hitesh basically talked about security, right? Security as an integral part of CI/CD, and basically having security ingrained in your DevOps, and not only that, but ingrained in your development as well, right? So right from the start of, let's say, code development, you need to somehow ingrain security as a core functionality and as a core behavior, right, among developers. So that is some of the motivation that we had to build this, basically the SAST framework that we have built called Patronus. So quick introduction. So I am Ashwin, joined by my colleague Akshansh. So we are both security engineers working here in CRED. So yeah, both of us have been about 2 years now in CRED. Yeah. So I'll just quickly walk you through the agenda. So we'll first look into why we built this, what is our motivation to build this, right? And we'll also see how Patronus sort of, the framework sort of stands out, right? From what you basically would see in the open source community, as well as the proprietary SAST frameworks that you can see, right? And further down, we'll also look into the design solutions. Then how we have basically trimmed down the false positives. We'll also look into a quick demo, not sure about the time feasibility, but yeah. And as well as the future roadmap. So this is something that we are planning for future as well, and how we will basically scale it going on, right? So why we built it, right? So if we did a lot of industry analysis and market comparison, right? And we found out there was a huge lack of, let's say, SAST frameworks. So SAST, to put it shortly, right? It's basically static application security testing, right? So right from when the developers are basically writing code, we wanted to ingrain security there. So a lot of these tools had a lot of gaps. So that's what we understood. All the proprietary tools, although we could just plug and play most of them, we found that there were a lot of gaps. They couldn't solve for a single security framework for, let's say, for vulnerability management as well as asset management, right? Not only that, any SAST framework you take, right, the top problem that you would have is that of false positives. So that is going to be a huge operational overhead once you think about scale, right? So let's say once you have, like, people were talking about, let's say, some 2,000, 3,000, 5,000 services, right? So that many tens and thousands of millions of lines of code will have like that many number of security vulnerabilities as well. So thinking about scale, when you build a framework that somehow generates a lot of false positives, is going to be a huge operational overhead. So that is one important point we somehow found to sort of trim down false positives and get it in a fine-tuned nature that people can generally have in an actionable sort of manner, right? So also, if you think about most of them, there's a very lack of sort of visualization on how the organization's security posture basically is, right? So you would maybe get stats around, let's say, metrics around how many vulnerabilities you found, all these sort of XYZ metrics, right? But if you want to sort of get the organizational like sort of security posture, like let's say CRED, how does it stand compared to our services, and where do we basically stand, right? If we want to do a self-evaluation, how do we basically stand? You want to get that security posture, right? And also, if you think about it, right, most of these are lot of these frameworks we found were in a very sort of blocking mode. They would sort of let's say you find some small even a false positive, right? They would basically block the whole pipeline. And these sort of issues is what we wanted to basically deep dive into. And if you also think about it, right, most of these don't cater to the developers themselves. So most of these are very highly operation expensive and are catered to, let's say, the security teams or the security operations teams, right? So what we wanted to bring here was a more developer friendly approach where developers and could basically use or leverage this framework right during their development, right? Even let's say before they could, let's say, go and deploy certain services, they could basically make sure that the code that they write is sort of secure in real time. So let's look at some of the functionalities that we built, right? So on a very broad level, we have like 4 key pillars, which are secret scanning, software composition analysis, software application security testing, and asset inventory. So basically, these are the 4 core pillars that we have, and we have sort of built a dashboard around this. So what the dashboard basically solved, I'll tell you. So it's sort of gave us a sort of a actionable interface to basically deal or solve for security, right? So most of what security tools out there would do is basically like they'll give you sort of reports or just random reports saying that, hey, this is a vulnerability. So how you would basically act upon it, let's say how you can basically solve that, how you can solve that in a more functionable and actionable manner is how we sort of try to build. And if you also think about it, like you would need to scan lots of code, right? Like if you think about scale, scanning the whole code base on a daily basis is not going to work out. So how we sort of built that around is by only scanning through the diff, right? So that would basically sort a lot of like it would first of all reduce the detection time for bugs, as well as it would basically sort of help us scan code bases in scale. And more on, like, we also have a lot of REST API support where you could basically use this this framework itself to build more tools around that, right? You could build like, let's say, automations, scripts, something that you want on top of this basic framework. So yeah. So let's broadly look into how this whole framework is built, right? So you can basically divide it into 3 major parts. So first is the initialization phase, wherein like let's say from where you basically get the triggers, right? So the triggers or pre-scans is how you basically get. So by default, it is configured for a daily scan, but based on any organizational needs, we can basically change that, right? It's just going to be a cron. And we are just scanning for the changes that have happened in the past day or last 24 hours. But we also have a functionality wherein like developers could, during development, right? It could be Slack, it could be anything, right? Whatever like apps that you use, right? So you can basically leverage Slack in our case to basically just go ahead and scan any code that you are writing on the go, right? So developers could basically just one Slack command, and you can use an on-demand scan feature that we have built to scan your whole code base. So as I mentioned, there are 4 key pillars, right? SAST, SCA, secret scanning, and asset inventory. So you can, yeah, I'll talk about that later. But for the on-demand scans also, you can directly leverage the dashboard. You have a UI dashboard as well as APIs, as I mentioned before, to use any part of our framework, right? So everything is supported by APIs, and you can basically even write custom plugins on top of that. So on-demand scanning, you can basically use it for, let's say, like some developer is writing and you want to quickly scan through one repository or one service, right? And you want a particular thing in mind, like let's say you want to scan it for hard-coded secrets. So you can basically go ahead and do that. It will basically clone from Bitbucket and it will clone it into the EC2. And basically in the in the scanning phase, what we basically do is we have 4 different types of scans, like 4 key pillars that I mentioned before, right? So in the daily preset scans, it basically scans for the whole things. The diff of the code is scanned for all these 4 things. So asset inventory, we keep track and keep metadata of all the new services, all the assets that we basically have, right? And in SAST, so there are 3 components you could say about any code, right? So first is any hard-coded secrets, right? So let's say you have some AWS keys and all hard-coded. It's going to be a huge issue, right? And you would have like massive impacts, right? So that is one aspect that we have focused on, which is the secret scanning. Then you would also leverage a lot of libraries, packages, third-party libraries and all, right? So the security of the libraries that you import is also very important, right? Not the code that you write, but the libraries that you import, right? And that could also lead to a lot of issues. Like classic example could be Log4j, which most of you might be aware of. So that is something that we solve using software composition analysis. And then the third part is basically the code that we basically write, right? So that is another key integral part. So we scan for, let's say, code patterns and basically for any sort of security vulnerabilities. Let's say OWASP top 10 and all these things are covered in SAST. So in the daily preset scans, the all 4 key pillars are processed, and then it's basically sent to an output file. And in the on-demand scanning, you basically have the like you basically can use any of these pillars, and you can scan like either or off. So that is something that you can right away do from Slack or let's say the APIs, right? So in the enrichment part, right? So we have fingerprinted each security vulnerability. So right from the 4 pillars, let's say Petronas identifies any sort of vulnerability, right? So we fingerprint that vulnerability based on one internal logic that we have, so that we can prioritize as well as we can score the severity, right? So for example, let's say a certain issue was found, and let's say there was a CV attached to that. So that CV, let's say, has a like it has a public exploit, right? Publicly available exploit. Like any script kiddie could just Google that, find that, and exploit, right? So that's going to be very highly critical for us, right? In terms of severity, it might be low or high, but it's easily exploitable, right? So that is how we sort of try to prioritize each bug, and based on that logic, we push it to the database, and that this whole report is accessible both to Slack. So let's say in the daily scans and all, right, we get a consolidated report in Slack directly. So any changes, or let's say you will also get, like, let's say how many bugs were identified in the past day, how many were not fixed, how many were patched in the last 7 days, right? So all these sort of metrics, and in the dashboard also you basically get to see like how these metrics basically went through, right? And you could basically also skim through, and there's a search function and all. I think Akshansh will cover that into more detail. And you also have a lot of custom plugins. That is something that we have really built on. So let's say you also have integrations to directly to Jira, Slack, or anything you can build, right? Because you have the REST APIs, and you can easily build custom plugins on top of that. So for example, that on-demand scanning feature is something that we built on top of this direct integration to Slack. Similarly, we also have this functionality wherein like any new service or security reviews raised, right? Petronas basically goes and in real time it goes and scans for any vulnerabilities and directly reports that in Jira. So if there is any sort of security vulnerability, it sort of blocks the ticket saying that, hey, you have to go fix this before signing that review off, right? So all these sort of plugins and sort of like functionalities you can basically leverage on top of the framework. Yeah. So yeah, Akshant will present more on how we basically trim down the false positives.
So when it comes to any open source tools, right, basically around security, the major problem we face is reduction of false positive, right? You'll get a lot of tools which have like lot of results, right? But none of them will be like 100% accurate and actionable, right? So how do we generate actionable results, right? That is why false positive reduction. So we have three components to it. The first is detection of active tokens and secrets, right? So everyone knows, right, how sensitive an AWS secret is, right? But detecting that with a highest accuracy is a challenge, right? So we have built mechanisms such as we detect and report only valid secrets, and that too based on top of prioritization, right? So suppose a developer has committed anything, right? But how do you make it so fast and accurate that, okay, this should be treated as a P0 and fixed as soon as possible, right? So we have built the mechanism such that the detection is fast and we come to know as soon as possible the secret is committed. Next is scanning of exploits and CVs, right? So let's take the case of Log4j, right? We all were terrified, right? Like how do we search? How do we know like we are affected? How many services are we affected, right? So we have built a logic, right? If any CVs is present, right? That is that has a public exploit available, right? Or even if a CV has come, right? Which has some info, okay, which repo or which library is being affected. So we have a way to detect like, okay, this services are being detected and you should fix it as soon as possible. The third is classifying based on CVS's score, right? Yeah. Okay, sorry. So third is basically an enrichment of second only. So once we have CVs, right, how do you prioritize? So we have a CVS score mechanism which will basically tell you like, okay, your critical and high findings are these, fix it as soon as possible. So this was on false positive reduction. Now let's look at the demo. So on first you will see that you'll get SSO login enabled, right? So based on security we have enabled like you can whitelist a sort of domains like at CRED we would be whitelisting CRED authorized emails such as to login. Even if you are behind VPN or on the public facing, that's the thing we have enabled. Now once you enter the dashboard, right, you will see something like this. So this will be the first page, that will be the dashboard. Dashboard page we have filled with a lot of metrics, right? So metrics help you to showcase your security posture and your organization mapping on how well you stand on the base of security, right? So first you will see the number of scans, then number of total assets or number of repositories that you have. Yeah. So these are all as of dummy data. This is not actual data that we have, just to let you know. This is just dummy data for the demo. Then third is number of reports. We don't have that much reports, we just generated it. That is then vulnerability not fixed in number of days. That is like 10, 30 and 90 days basis. Then other thing we have is the graph. So graph will showcase you based on SAST, SEA and secrets, basically like how was your mapping across the entire area, which year or which month was exactly the highest count. So you can see April and October had highest count for secrets, right? Then coming down, we have also added some more things. Yeah. So you will see tags based on secrets and based on vulnerable classes, right? That are based on like secret tags, example of AWS. Then other is based on vulnerable classes, that will be SQL injection, XSS, and based on that. Then we have vulnerable repositories and number of repositories which have highest bugs, based on such that you will be able to visualize and map it accordingly. At the bottom, you'll be able to see that we have an exploit trend, right? So we have a mapping based on number of days, example like 0 to 30, 30 to 90, 90 to 180 and 180 plus days, right? So you can see like, are these bugs even getting fixed, right? Like if you have bugs being generated, are being actively fixed, and what's the exploit scenario. Then we also have a vulnerability age. So this will be based on SAST, SC, and let me go back. Yeah. So this will be based on SAST, SC, and secrets. Coming to this asset inventory, right?
So whatever we data collect, right, like all the repositories that we have, we collect them in the asset inventory. So we categorize them based on top languages and top 10 images being used, right? So when I say about images, this is basically Docker images. And for languages, we scan based on all repositories, and all repositories languages are being scraped, and we get to know on them. In asset inventory, you'll also be able to see and search like what all repos you have, creation date, language, and image name. Yeah. Now look at all the three modules. So we'll cover SCA, SAST, and CRED. So SCA will be software composition analysis, all the dependencies that you have. So we are covering as of now Node.js and Java. So based on that, whatever vulnerabilities that you have, right, we'll be showcasing that and categorizing that. So one of the features that we have built in is getting actionable output from the dashboard, right? So you'll be seeing the three things on the right hand side. That is basically marking it as true positive, marking it as false positive, and finally raising Jira of the same issue, right? So this is enabled for all the three modules, and this is like one feature that we wanted to build. All the open source features that you see, right, all the open source tools, sorry, that you see, like, won't be having an extension or actionable results, right? But the major motto of building our own in-house tool was that we should be actionable and be fast in detecting. Yeah. Yeah, so we earlier, right, the false positive reduction, it's after that only. But like even after that, right, you will be seeing like, okay, issue is correct, but it might be a low priority, or it might, correct. Hmm. 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 Yeah. So this is for SEA, right? When you click on any result for a particular result, this page will open. So this will showcase you your vulnerable repo, the description of it. It will give you a CVSS score if it assigns it to you. Then creation date, has it been, does it have a public exploit, and which scanner did you use? And two more interesting things that we have built, that is the same vulnerability present across other repos. So we showcase as our top 5, but you can configure it from the 5. And one final thing is how to remediate. So we give you the patch version, so you can immediately ship it on top of that. Now let's look at other two, secret scan and SAS. So we are cut short on time, so we have to run it quickly. Yep, this is for secret scan. So for secret scan, the dashboard looks almost similar, but let's open our results and show you in more detail. Yeah. So for a particular secret scan, right, what we are additionally adding, like the details of developer, tag, file name, commit, etc. Right. So you can see, you'll be seeing the affected line, which line was exactly affected, who was the developer, who committed it. And for raising Jira, right, this becomes very easy. So in Jira, the developer will be automatically tagged. You don't have to manually add or do anything. Similarly, we have a view file functionality as well, right? So this will directly open the commit, and you can actually verify before even raising the Jira. And one more thing is how to remediate. So I'll just walk you through. Yeah. So we have listed in all small steps basically how you can remediate. These are a set of small 10 steps in which you can remove not only from your cache but Bitbucket cache as well. Yeah.
The problem is hard-coded secrets. So we have to so the major problem with hard-coded secrets, right? So even if you, let's say, remove it from the top commit, right, it still first of all remains in the history, Git history, and even if you remove it from there, right, so Bitbucket again will cache it, right? So even still that history will be even if you remove it from history, that cache will be there, right? So we basically skim through like, okay, what are the next problems, and we made our own SOP which we share internally to the developers and all to get it fixed. So that is what we basically list. So this sort of thing is just a dummy dashboard, but yeah, so mostly all vulnerabilities will have some remediations and that SOP on how to get that fixed.
Yeah. Yeah. No, we are like manually. Yeah. So yeah, this is our third and last module, that is SAS. So it also looks similar. The only change will be you will be able to see the part of vulnerable code which is there and which has been detected, and you can see what was exactly that was causing the issue. And similar features will be available for that you can resolve, mark as false positive, and raise Jira. Now let's look at the most interesting thing that we have built, that is on-demand scan. So in on-demand scan, basically you'll have the flexibility of going and scanning repos on the live, right? Live repos you can scan. So we had an cron that would scan daily, right? But let's say you want to test a repo now, right? Let's say you want to test it, like you have just made a new repository and you want to test it, and a specific branch and a specific type of scan, right? So you can do this via dashboard. So dashboard will give you that flexibility. Yeah. And this is this you can also configure via Slack. So we have a Slack demo as well. So as you can see, you selected a repo, a branch, and a type of scan, and yeah, it will show you status as well. So we have an auto refresh as well. So this will show you the status of the page. Yeah, so there was this one, and once it's completed, it gives you the result in whole format. So this will be combined of secret scanning, SAS and SEA. So you will see something results like this. And just iterating through the Slack as well. So this is a Slack bot that we made. Yeah. So on Slack also you will be able to type and get the results in the same way, and the speed and accuracy will also be similar. So this is us typing the repository, the branch, and the type of scan that we want. Yeah. So it will show you your scan has started and your results will be posted. Yeah. For a normal scan? Yeah, so this was part of the demo. Yeah. Yep. So part of future roadmap that we are building, I'll just cover you quickly. So we are adding SBOM and license management as part of Petronas only. So license management is a huge issue that you or might have seen, right? There are packages, libraries which have particular license, particular dates, expiry, things like that, right? So we are building a part of in Petronas only. Second is SBOM. So once we have a dependency, right, there might be like there are child dependencies inside that, right? So we have mostly built SBOM. We'll be slowly rolling it to Petronas as well. Then we have new things like coverage for more languages. We are slowly rolling out coverage for more languages such as Ruby, then in SAS and SEA, Golang as well. Then one-click automated patching of SEA issues. We currently only showcase you the version and remediation part, but we don't actually do like raise a PR or do something on top of that, right? So we are slowly testing that and we'll be rolling out by next 2 months. And CI/CD integration that we just talked about, right? We are not in a blocking phase as of now. So once we completely have tested and thoroughly have gone through the CI/CD integration, we'll be also adding it in our open source. Yeah. Yep. So this was from our side. If you have any questions, we'll be happy to answer this.
Yeah. So the motive for SAS, right? So static application. So it was that we wanted to try to sort of bring in security into the developers' workflows, right? So we wanted to see how we could sort of integrate that security workflows within their own culture. So when let's say developers write code, right, even before deployment. But DAST is a separate solution that we are trying to yeah, but that will be covered by DAST. So that's sort of a different problem that it's not solved by this.
Yeah, you asked something.
So there are two aspects of the scanning. So one is the daily scanning that will be happening. So that usually happens around night time when there is no development activities. And the other is the on-demand scanning, right, where you can just go ahead and hit the right top commit. So it will basically check for the diff from the top commits only. So that would be sorted. And if it's a daily scan, the possibility of that happening will be very low. But even still, if that security vulnerability is actually identified, you can just go to the dashboard and mark it as false positive.
And in case of secrets, right, even if you remove in like let's say top commit, the commit will still be there, right? So that's a necessary step like we have to take like to remove that, right? So that's also
that even if you just remove from the top commit, it's not going to solve. So you will have to go through the proper.
So front end is made in I think Vue.js. Backend is made in Python. Yes, this is open source. This is entirely open source. Like
the whole framework,
is open source. Yeah.
But you can also like build on top of build plugins on top of this. So those plugins we have not. Any more questions, please? So yeah, we are hiring.
Yeah.
So in infra and security, we are hiring. So please go to careers.cred.club. Please reach out to any of us. Harish, you might be all knowing. So reach out to him for any roles and openings. Sure.
Thank you, everyone.
Probably the audio system is not picking up. So okay, so generally September is the time when we have our event at Yahoo. So I'm not very sure if Yahoo is still like 60-40 or what is the kind of a thing that people are going to office. But we already have a proposal from Grab that if we need to do our September event in person, obviously we'd like to do in-person event in this kind of hybrid mode. So we'll between Yahoo and Grab we will see, and generally our cycle is second Saturday of every third month. This was the third Saturday, by the way, so we had to push it because of the host arrangements and all those stuff. So we'll have the 44th in September for sure. I could see CNB there, so great. CNB, you have a few words. Okay, thanks to Grab for hosting us, and thanks everyone for coming. So let's meet to the next event. Follow us we have a Slack channel these days. I don't know, something happening in mind. So CRED, thanks CRED. Apologies for the incorrect. At the end of our long day, everybody's ATPs are not working the way it should work. Okay, so all good. So let's meet at the next event, and in the meantime, what we didn't do this time is we didn't stream it directly to our YouTube channel. So once I get this stuff done, so we'll load for references. And if you want to, if any of the speaker would like to share the slides, share us the link, or we'll drop a note to all our members. Thank you.